this computer. Cool. So, so yesterday, you started on introduction to security and did a few things, and you even went all the way to touching a bit on network hardening. So on network hardening, if I am well briefed, I was told that we stopped at ping. We stopped at ping here. You stopped around, was it there? Let me check. Kidogo. Yes. So we stopped at ping, but I'll take us back kidogo because I just want us to flow. I want us to flow well. So so network, we told you that everything in the cloud, even on the on-prem environment, succeeds or fails due to how those various components of that system are connected. And what connects these systems are what we call networks. So networks can be wired or wireless, the way we had already discussed in the previous classes. And so now when you're talking about network hardening, we are looking at how best we can secure these networks. How best we can secure these networks, because believe you me, these networks are actually like entry points that can be hijacked by threat actors, and by threat actors I mean hackers. They can actually attack an entire organization just by exploiting vulnerabilities within a network. So it's very, very important to make sure that your network is hardened or your network is secure. The example I gave you when we were starting about the layout, the security layout of where I stay, where you see like we have a gate with a watchman, then we have a door, then we have this door has locks, then after that layer, then we have these different rooms. It's just like an example of how we can say that is how my place has been hardened in terms of security. So even for your network, you need to make sure that your network is hardened, and there are various things that you can do to ensure that your network is hardened. So we will pick up from network mapping. We'll pick up from network mapping, and we'll say that network mapping actually exposes the topology of a network. You know, network mapping exposes a topology of a network. So what is to map a thing? If you want to map an area, let's say, for example, you want to map Kiambu County, for example. You want to map Kiambu County. One of the things that you will do, apart from saying that within that map, we have this estate, we have this village, we have this hospital here, we have this chief's office here, we have this church here, we have this mosque there, you know, we have a market in that other place. We'll also have roads. So it is roads that will be leading you to these various places. It is these roads that will be leading you, say, to the market. It is these roads that will be leading you maybe to the hospital. It is these roads that will be leading you maybe to a bank. And in this map, if you live in Kiambu County, you will also have your house within the map. So if you want to move, say, I want to move from my house and say, go to the supermarket, there's a specific route that I will follow. There's a specific road that I will follow. So say my house is here, and then I want to go to, say, the market. So that way, we can, when you go to the cloud, I can use an example of my house is the EC2, and then say, for example, the market is an S3. So I want to move, traffic wants to move from, say, my EC2 to my S3. You see, it is following a certain network. I hope that one makes sense. So for you to make sure that your traffic flows seamlessly and your traffic flows without any problems, there is need for you to ensure, that any threats within that route that you're following or within your network, any threats within your network are dealt with. They need to be dealt with, and you deal with them by hardening. So we are told here that attackers can use network maps to find out which devices and hosts are present in the network. Examples of network mapping commands and tools include the following. We talked about ping, which determines the IP address of a host. We talked about traceroute, which identifies network path and devices that are message traverses to reach a host destination. And then there is nmap. Nmap discovers which hosts are on a network. You know, it discovers which hosts are on a network. So the same way we have these tools that network engineers can use to check different aspects of the network, also threat actors can use these same tools to do what we call reconnaissance. reconnaissance or discovery. So before an attack is launched, the first step of every attack is normally reconnaissance or discovery. Or reconnaissance, there's another name for it, which we call previsit. Let's say, for example, you wanted to do something on a site before the D-Day, you do a previsit, and then now you go and do the main day visitation or the main day thingy that you wanted to do. So these are the three tools that you can use: ping, traceroute, and nmap. And we've been told that ping is for determining IP address of a host. Traceroute identifies the network path and devices that a message traverses to reach a host destination. And then we have nmap, which discovers which hosts are on a network. The notes explain what we've just talked about. And then we have this screen here that shows us a network mapping tools example for ping and traceroute. And remember, I told you, for those who are on Windows, we use traceSat, not traceroute. Traceroute is for Linux and Mac. So when you do ping, it's supposed to return the IP address of the specified host if it can be reached. It will only give you back the IP address if it can reach it. A timeout is if the host does not respond within a specified time. And an unknown host is if the host does not exist. If you see something like unknown host, it means that the host does not exist. And then timeout is if the host that you are pinging is offline. Like, for example, I remember that day I ran a ping to cloud4sky.com, which I knew very well is offline. So we did not get an echo back. We did not get an echo back, so it did not give us anything. Then for traceroute or traceSat, the route that IP packets take to reach the specified destination, that's what it prints. So traceroute or traceSat, just look at that. Traceroute, it traces the route that IP packets take to reach the specified host. So the IP address of each host, the IP address of each host that is encountered along the route is also printed. And then asterisks are printed if a host along the route does not respond within a specified time. So if a host along the route does not respond within a specified time, asterisks are done what? Asterisks are added. Like, for example, in this example, as you can see down here, let me make it a bit bigger for you guys. You see? So here they ran traceroute for Amazon.com, and then so traceroute to Amazon.com, it gave 128 hops. Those are like the various steps that the packets take to reach Amazon.com. And then we have this asterisk. We have this asterisk. Then we have a domain here with its IP. The time it took, and then asterisk again, we have a domain, IP, and the time it took. So that is what you should be expecting when you run your traceSat or traceroute. So the slide above just shows you how ping and traceroute do its thing. Okay? How it does its thing. So that is very, very possible. That is very, very possible. Awesome. Then what do we say about port scanning? So here, first of all, let us take a breather here, and one thing that we've said, firstly, you start by making sure that your network map is hidden, your network map is secured, your network map is hardened. Firstly, so that if it's ping, and you'll see in the subsequent slides that there is a way that you can actually harden this so that not everybody can just do that. I don't know if you guys have ever heard of this kind of attack called DDoS or DOS attack, denial of service attack. So denial of service, hackers. It is not that all DOS is actually hacker related, but most of them are hacker related. And nowadays that we even have AI bots that can be used by hackers to execute these attacks, it becomes even worse. So we have the DOS. DDoS in full is denial, distributed denial of service. Distributed denial of service, because now with DDoS, what happens is that the attack is not coming from a single device. It might be coming from multiple devices. And when you get into doing security and you go into security in depth, you will discover that it's very easy. You've heard people talk about bots. Bots. So these bots that are used to execute these attacks can easily be like, say, my computer, your computer, another person's computer. Any computer that is within the internet can be infected and used by these threat actors as bots to attack other systems. So that's one of the things about they are called botnets. Thank you, Salem. They are called botnets, and it's true, Rich. Some of these are state sponsored. Some of these attacks are state sponsored because people have their own reasons why they do these things. Some do it just to frustrate. Most do it for financial gain. Most do it for financial gain. Others do to cripple competition. So all of these things happen. They happen for different reasons. Say, for example, you are a big shot e-commerce site that wants to launch, and then you have set your launch date to a specific date, and then a competitor hears about it, and then this competitor is not a very good competitor. They decide that they are going to teach you some stuff, bad stuff, I mean, and so they hire these threat actors. And recently, I was in another security class where we were being told that nowadays there is a hire me a botnet. Hire me a botnet, as in there is a service. It is not found on the internet. It's found on the dark side of the internet, that you can actually go and hire a botnet. And a botnet, that is a network of bots. You can hire that, and then you're even given a manual, and you pay for the service. They tell you maybe for 10 days or 30 days, this is the much that you're going to pay in Bitcoin. So you pay. Once you've paid that, they give you the direction on how to use it. And then you just input, for example, just input the IP address of the system that you want to attack, and everything else happens. But I'm not trying to teach you guys to be bad people, so I'm not going to talk a lot about that. But this is what normally happens. This is what normally happens. I believe to be aware is very, very important, so that you can protect against it. You can protect against it, especially for guys who will be going into security. You'll discover that we will be taught things like you will be taught things like red teaming, blue teaming. You'll be taught things like playing defense. You'll do a lot of penetration testing. Penetration. And when you're doing pen testing, one of the things that you'll be doing, you'll also be trying to penetrate networks. You understand? You'll also be trying to penetrate networks. Actually, a friend of mine the other day told me that even in their course, he's a data scientist. He told me that there's a course that he took, and he wondered why they were being taught about hacking. And then he told me that, one thing that we do, we ingest a lot of data, and some of this data are behind paywalls. So we need to know how to safely go behind these paywalls and get the data that we need. The data that we need. So in hacking, you'll come to discover that there are actually 3 levels of hacking. I hope that there is a time that we'll talk about this in depth, but there are like 3 types of hackers. There is a black hat hacker. That is just like the bad hacker, black sheep. Black hat hackers are the bad ones. And then we have the white hat hacker, the good hackers, or AKA the ethical hackers. And then we have this 2 other type of hackers. They are called the gray hat. So when you add black and white, you get what? You get gray. So these gray ones, they are in between. They are in between. So yes. So I'd rather you stick to the white. Because there's a very thin line between gray and black. It's very easy to turn black than turn white when you are gray. It's very, very easy, because you can easily say that gray is light black, but you can't say that it is dark white. You understand? So it is very, very easy for you to turn black. So better stick with ethical hacking. because if you hack a system without permission, you are actually considered a black hat hacker, and that is not a very good thing. And we've had news, we've had things on the news like a bank, someone I think I saw some news as recent as yesterday. There is this guy that siphoned I don't know how many millions from CDN Bank. Someone hacked their system, and then there was also a DTB issue, and other banks have also suffered. Other banks have also suffered, yeah, including also insurance companies. So you can see the role of security engineers is there. There is that. And again, there was some news some time back, I think it was 2 months ago, where banks were decrying shortage of cybersecurity experts in the market. You know, they were decrying that. They are decrying that. And yes, it's true. It's true, Salem, that hackers should be employed, not imprisoned. However, hackers should not be doing black. You see, some companies are cautious. Yeah, they employ you, they put you in, and then it's not even about expertise. It goes beyond expertise. It also touches on your own principles, on your values, on your morals. Yeah, because if we employ you simply because you are a hacker and then you come in, we will have significantly increased our insider threat. We will have significantly increased our security vulnerabilities from insider threats, because you've just brought in a hacker who does not have morals. They don't have good values. So don't let movies lie to you that, oh, a hacker has been caught somewhere. I think, was it Mr. Robot or something? Movies like that a hacker has been caught, so the CIA has transformed them, and now they're working for the government. Yes, that one happens. It happens in some cases, but not in all cases. It's per case basis, and some of these companies are now getting to a place where they are employing very good hackers to counter hacking attacks. Yes, and Joy said yes. Botnet as a service is called BAS. Yeah, you see, BAS. You remember we talked about PAS, IAS. Yeah, now we even have botnet as a service which can be purchased from those dark places. So that is very, very important. So it's very important to protect yourselves against that. Even you as how do you call it? Even you as someone that works on the internet, it's very, very important that you also have some layers of security to protect your own computer. I don't know if you guys heard about this attack that happened, was it 2 years ago? Called ransomware attacks. I don't know if you guys heard about it. It was so severe. It was so severe. And you wake up in the morning and then you find that all your screens have been locked, and then you have something there, and then it's telling you that, oh, for you to get access to your system, you have to pay this much. That is what we call a ransom. It's like they've now hijacked your system. Now you have to pay. Yeah, you have to pay this ransom so that they do what? So that they can now release your system. Or some even went to the extent of telling you that if you don't pay, we are not just going to crash your system, we are also going to mine data. And then some of these sites had a lot of client data, so you either pay or you get problems. And interestingly, it was around that time that I started getting interested in IT. Long story, I'll tell you one day. And it's what actually caused me to transition and get into IT security. So ransomware attacks were very prevalent. So apart from network mapping, it's also important for you to do what we call port scanning. Now, at least as at this time, you already know, guys, you already know these things to do with ports, because we've talked about ports. And when we were talking about when we were talking about ports, we told you, like, for example, different type of traffic accesses systems or networks through different ports. For instance, who can remind us what is the port for SSH? What is the port for SSH? Port 22. Thank you, Salem. Thank you, Sandra. Thank you, Gideon. Someone tell us, what is the port for HTTP traffic? HTTP. Port 80. Very nice. Very nice, Sandra. Thank you, Habakkuk. Thank you, Rich. Yes. Now, let me take us a bit deeper. Just one more. Who can tell us what is the port for HTTPS? 443, nice. 443, nice, 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 nice. So in the process of time, we will give you a chart that shows you different traffics, the common traffic types and their ports. Common traffic types and their ports. And that's a very common question when it comes to interviews. If you are doing an interview for a cloud engineering role, a DevOps engineering role, that's a question that features predominantly. And it can feature even as a scenario-based question, not just a question like I've asked. Like maybe they can ask you something like you discover, like for example, the question we got in our checkpoint when we were talking about SSH, where we were saying that, developers have reached out to you as a sysadmin, and they've told you that they are not able to SSH into a system. How will you resolve that? So the first thing to do is, first of all, to check if the security groups allow for inbound traffic on port what? On port 22. You see stuff like that. So port scanning is very important. Now, we are saying that port scanning exposes available protocols and services in a network. Port scanning sends, so when you're talking about protocols are the likes of SSH, HTTP, HTTPS, so port scanning sends packets sequentially to ports on a host to determine which ports are open. So when you're doing port scanning, you're trying to check which ports are open. Attackers can use it to find which protocols and services are implemented on a network. Nmap is an example of a port scanning tool and does the following. So for Nmap, it helps you determine which protocols are supported by a host. It helps determine which ports are open on our host. It identifies which services are connected to open ports. Which services are connected to open ports. So later on, when you get into doing your own projects, or when you decide to take up a role, you might discover that all of these tools that we've talked about, they can either be used by a good actor or a bad actor. So a bad actor will do port scanning so that they discover, like, for example, which protocols do you support? So that even when they are writing their vulnerability scripts, they will make sure that they use the same protocols. Equally, they'll want to know which doors or which ports on your network are open. So that, again, when they are writing these vulnerability scripts, they will direct these scripts to those open ports. And as we normally say, it's very, very important for you when you're dealing with ports to make sure that you only have you only have enough ports open, the ports that you are using. The only ports that should be open in your network are the ports that you are currently using. Don't make all ports open, because if you open all ports, you are increasing even the threat surface. You are increasing the threat surface through which these guys can come in. So you have to make sure that you only have the right ports open. And how do you make sure you do that? Again, when you go back to our security groups, you will see what we define. When we say allow inbound traffic, sometimes you don't say allow it from anywhere anywhere IPv4. Anywhere IPv4 can be so open. But if you say allow this, allow this from, you can say from my system, maybe from my IP, because I have my own static IP. So just allow it from my IP, not from anywhere else. So that is very, very, very good. Don't where Salem, don't put scanlandyafrica.com and then you figure out the need that you're using. Don't do that. Don't do that. Don't do that. Don't do that. Are you planning to do something? Are you planning to launch something small? Okay, don't worry. Don't worry. So most of these things that we are doing, most of these things that we are that we are learning here will make you a better engineer by you knowing them. By you knowing them. Remember, security is a shared responsibility. Leave alone the shared responsibility model in the cloud. Even in an organization, security is a shared responsibility for everybody in that organization. Right from even the people who cook tea for the organization, they are also responsible for the security of the organization. All the way to the CEO. I mean, from the lowest person in terms of rank in the organization to the highest person in that organization, security is their joint. It is their joint responsibility. Let me try something and see how this one. Let me try it first before I tell you how it does. Give me a sec. Sometimes I don't like running these commands because Windows has got its own way of doing its own thing. So, let me use. So again, you see Nmap is not recognized on my system. Let me try this other one. Give it a sec. Sorry, guys. Excuse me. I can see you're a good hacker. Salem, I can see you're a good hacker. You're asking for permission. Okay, so just a second. Sorry. Just a second. Let me try pinging something to see if it's online. Ping. Okay. So we try. Paste it. Oopsie. Oopsie. Hasn't happened. Just a second. And map exe. Then we do what we use the IP dot dot 63.186. Okay. Nmap has refused. Nmap has refused. Okay, we just leave it as that. Just take it as is first. Because now what will need to happen here for this to run well? What will need to happen first of all is to set environmental variables on Windows for Nmap. So about try running because you want to try. Let us try running with a system that I know is already secured. Try running nmap.exe Salem on google.com. Try running it on google.com and then give us the screenshot of what you are seeing. I don't know if they will allow it. Maybe they have blocked their ports, but try running that. Try running that. So you see here, we are being told that in the example above, Nmap is used to perform an IP protocol scan on the host with IP address. So there is this IP address, and then the command also specifies the port. So we have port 25, port 80, port 135, port 137, port 139, port 445. So all of these ports are being scanned. Then the intent is to determine whether any of those port numbers are open on the target host. So they are trying to check if any of these ports are opened, and you'll see sometimes, especially when you're building a system, a web application for the internet, when you try to run it, or rather, say for example, you decide you package your code as a Docker. Okay, you package it as an image on Docker, and then now you want to run it. You will have defined which port you want it to run on. You'll have defined which port you want it to run on. So that's why sometimes you find people with HTTPS, all the URL everything, and the domain everything, and then colon the port number. Then when you put the port number there, you will see if it runs. Like for instance, again, just mentioning in passing because we'll deal with it when we are doing DevOps tools. When you're using Docker, for example, you can actually map ports. There is a specific port for Docker, like let's say port 8080, port 8080, you say you want to map it to port 80. So it means that whatever was supposed to run on port 8080 will also run on port what? On port 80. That's what we call that's what we call port mapping. That's what we call port mapping, and we'll talk about it. So Ridge has ran something. Let's see the result he got. Yeah, so you see, are you seeing that? Are you seeing that? So this is Nmap. So if you run Nmap and you run it on google.com, right? Rich? Ah, yes, cool. So it is showing us that it has discovered an open port 259, protocol TCP, and then you can see this is the IP. You see, all these ports are open. All these ports are open, but again, you know that is Google. You cannot just launch an attack to any of these ports. These ports, in as much as they are open, you've discovered yes, they are open. So when you are trying to write your script, you will be trying to direct your traffic to any of these ports, because ports are like doors. You cannot just enter into a building without going through a door, So they have like 1,000 ports in total. Wow, that's big. They have like 1,000 ports in total, which are open. And you know why they do that? Because remember, this is google.com. Google serves so many people. So in your organization, you might find that that the ports that are open are not as many as that. I'm curious. Ebu, try for facebook.com and let us see how many ports are open. Try for facebook.com and then tell us. I just want to know the number of ports that are open as we continue. So that command, the nmap.exe, the nmap command returns information about the state of each port and the name of the service that is listening on that port. Like we've seen in that example that I've just shown you, we have kiasi, open up, FBI. No. You are not attacking anybody, so you are still trading on the safe side. So name of the service that is saying on that port. In that result, for example, you've seen that port 80 is open, and in this other google.com example that you've seen from Rich, we've seen that there are other many ports that are open. And we know that for port 80, the service name there is normally HTTP, which indicates that HTTP service is running and listening on port 80. So the command also identifies the OS type of the target host as Microsoft Windows. That is from up there. And I remember, if memory serves, there's a time that we were talking about, we were just mentioning these types of attacks, and Musembi had said something about traffic sniffing. Yeah, so Facebook also has 1,000 ports in total. Wow. So 1,000 is like the golden number for these big organizations. 1,000 is like the golden number. And because there is no harm in it, also run one for landlyafrica.com and tell us how many ports are open. Just tell us how many ports are open, and then we will know. Okay, cool. So, Salim, you're waiting for that, eh? You're waiting for that. Don't think that you can hack there and then mark all your labs as done, or give yourself a grade that's not yours. Eh? Like I remember there are guys who hacked their school and gave themselves graduating marks, forgetting that everything that is on the system is backed up somewhere. And if they already know that you are you are not doing very well in your first and second year and third year, yeah, I'll not work KU, of course. I think it was JQuat. Was it KU really? I think it was JQuat. Okay. What your JQuat, Siwachomei? I hope I'm not banning for you. I'm not banning for you. Let's see. Okay, so this is Lanley. Okay. So we have these ports opened. So how many ports do we have open in total? And I like that. You see, we have 979 ports which are closed. So yeah, so we have like 979 ports that are closed. That is very, very nice. So the ports that are open are just ports that are needed to work. And you see, when you see SMTP and POP3, those are ports through which email travels, Those are ports through which email travels. So that is very, very good. I think I really like this network scan. This result is very good. Result is very good. With the process of time, you'll be able to read these things and just understand what it makes. If it makes sense, it makes sense. You can see the IP address for landlyafrica.com. And remember, Landly Africa has like 3 IPs, 3 IP addresses, and that's very nice. That's very nice. Okay, cool, cool, cool. This is good. This is good. And the easiest way to do it, the easiest way to know how many ports are open is you just subtract 979 from 1,000, because 1,000 is like the golden image. It's like the golden number. And then you'll have a rough idea. So that is very, very good. Cool. All right. So traffic sniffing. When data travels on information superhighways, or rather on networks on the internet. And something that most hackers like doing is to sniff traffic. And we say traffic sniffing exposes the information that is traveling through a network. And sometimes when some of this information, when they are sniffing it, there is a way that hackers can actually go as deep as getting to know the exact type of information that is traveling. If this information has anything that they need, yes, guys, restart your labs. If it has anything that they need, let me see if my lab was still running. I hope I'm not timed out. Start. Oh, I timed out. Oh, but then I had ended my lab because I had finished it. I was doing it before this session, just to make sure that everything runs as it should. Okay, so we are saying traffic sniffing reads the data in all of the packets that pass through a network interface card. By now, you know what an NIC card is, or rather an NIC is, or when it passes through a network device. So attackers can use it to read any unencrypted data that is passing through a network. That's why when we get deep into security, you'll understand that there is something we call encryption of data, which is very important, because with an encrypted data, it is impossible for someone that does not have a decrypting key to read that data that is encrypted. So encryption helps to make sure that your data travels safely. Your data travels safely through a network. Then Wireshark is an example of a traffic sniffing tool. It captures network traffic data for multiple protocols. You can use it to interactively browse the data, and it also saves the data in multiple formats. Wireshark, a very important tool for hackers of all types and flavors. So you will okay, maybe let us just look at something about protocol analyzer tools, which are typically used for traffic sniffing, because you can use them to watch and store all traffic that goes through a network. Wireshark is an example of an open source network protocol analyzer. When you are doing anything hacking, be it ethical, okay, when you're doing an ethical hacking course, Wireshark will feature predominantly as one of the tools that you'll be taught about. Then you can use it to capture the traffic on a network and browse it interactively. Wireshark also supports many different network protocols, as you've said, and you can also use it to store data in multiple formats. So that lab, Purity, it's lab number, let's see. Using Amazon Inspector for Vulnerability Assessment Remediation. What lab number is that now? Let's see. Let me find it for you. User groups, networking, security. So under security, we have this lab. Oh, someone has already found it, 276. Yes, it's lab 276, network hardening. Network hardening, cool. Thank you, guys. Okay, awesome. So where are we at? Yes. So we have talked about Wireshark, and this is a screen grab from Wireshark in action. So Wireshark displays the contents of packets that are passing through a network interface. So you can see everything here. It shows you the source, the destination, the protocol. You see length and additional information, all of this. So guys that are deep into pen testing can actually make sense of this. They can actually make sense of that. So the top part lists all packets that are flowing through the selected network interface. And when you select a packet in the top part, the middle part also shows the packet's detailed properties. These properties include things like the size, source, and destination, MAC address, and protocol. The bottom part, of course, displays the packet's content in hexadecimal and text format. All right. Now, we have talked about things that you can do or things that even a bad actor can do in terms of network mapping, in terms of port scanning and traffic sniffing. Now, let us move our discussion further and talk about network discovery hardening. Network discovery hardening. So, preventing network discovery. The goal of network discovery hardening is to keep attackers off the network. You want to keep these attackers off the network. And why do you want to do that? One is to protect against network mapping and port scanning. And we do this by restricting the use of or disable network discovery protocols. And remember, when we are talking about additional protocols, we talked about 144 ports. 144 ports is good. For a mid-sized organization, it's good. It's good. So, to protect against network mapping and port scanning, restrict the use of or disable network discovery tools, protocols, such as ICMP, that is Internet Control Message Protocol, and Simple Network Management Protocol, SNMP. So you can disable these ones on your, you can disable them on your network. And then you can also protect against traffic sniffing by following these measures. One, disable promiscuous mode on NIC. You disable promiscuous mode on NICs. So promiscuous mode is like that which makes everything open. I don't know why they came up with that name promiscuous, but anyway, they say disable the promiscuous mode on your NICs. Use switches instead of hubs in a network, and you know why? Remember what we said about hubs? Hubs allow traffic from everywhere to get to those hubs, and then it only allows them in if their destination, if they carry the right information that gives them access to the particular hubs. But for switches, the information goes directly to the destination without going to the other switches that are not that are not authorized to read the information that is coming in. Then, of course, it's very important to also encrypt sensitive data in transit, and we talked about this when I told you guys that it's always important to encrypt data, because only the person with that decrypting key will be able to read that data. So in the AWS cloud, we use a service called Amazon Inspector to discover unintended network exposure vulnerabilities. So in AWS, we use a service called Amazon Inspector to discover unintended network exposure vulnerabilities. So start paying attention from here, because what happens is that now that we start talking about Inspector, and actually Inspector is what we'll be doing in the lab. When we start talking about Inspector, we are now getting into the services. And these services are very important because I told you that it's the services that come in exams. So you might be asked, what is the role of Amazon Inspector? So start paying attention from here and start understanding what Inspector does. What Inspector does. So when we were talking about promiscuous mode, before we go back to our Inspector, when we are talking about promiscuous mode on NIC, we are told when NIC is configured to run in promiscuous mode, it reads all packets that pass through the network. All packets are read regardless of whether the NIC has the packet's intended destination or not. All packets are read. If an attacker is able to sniff the traffic on that NIC, they will be able to see all the traffic on the network. That's why you disable it. That's why you disable it, so that you just reduce the threat surface. You understand? You reduce the threat surface. Two, use switches instead of hubs in a network. So a switch can mitigate sniffing attacks because it will forward packets, not this, to only the intended destination port. This port is identified in the packet. On the other hand, a hub broadcasts all incoming packets to all the destination ports connected to it. So for this reason, as at 2022, the use of hubs in a network is extremely rare. So don't try to become a champion by trying to use hubs when you know very well we've been told that hubs have issues. Then encrypting sensitive data in transit. Of course, we talked about this. Hardware device or a software can be used to encrypt the data that flows through your network. You will learn about protecting data in a subsequent module. Yes, there is that bit that you'll be learning. So to help network discovery, hardening in AWS cloud, we said you can use a service called what? Amazon Inspector. And this service provides functions to discover network exposure vulnerabilities. So let me take a breather and ask, are we together up to that point? Are we together up to that point? Tuko pamoja? Are we together? Are we together? Are we together? You know how you react when we are together? You throw a thumbs up. Ridge is loving this. Hey, Ridge, I can see you. I can see you. I can see you. Mnasemanga nakuonea 18. Eh? I think you and Salim, you can make a very good tag team for network for network and security engineers, and then you bring in Belinda. You know, this work can become a bit tiresome, so you need someone that will make you people laugh. You bring in Belinda, you add Brian, you add Fan. You see if you can pull in Silas. Kidogo kidogo you chungulia if Sandra is available for the team, you know, Justin hapo, you know. So yeah, so network hardening is a very interesting topic. Very interesting. It's very interesting. Yeah, it's actually possible. In the cloud space, in the cloud space and generally even in IT, you can become your own boss. It's very possible. Awesome. Cool. So I guess we are good. So let us talk briefly about Amazon Inspector. And this one is for network reachability assessment. And so we are told you can use Amazon Inspector to assess the network exposure of Amazon Elastic Compute Cloud EC2 instances, and not just EC2 instances, but you can also use it to check other stuff, and you will see them. Let me see if I can still access. Can I really? Let me see, where is my lab? So my lab is running. So let me go to AWS. I want to show you guys something. Click here. So close this. So click here again. Cool. So we are talking about Inspector, and because I recently used it, so it's still listed. But for you, you'll go up there in the search bar and then type Amazon Inspector, so that you will be able to see how it works. So for you, the first step that you will do, okay, you will meet this questionnaire. So you just need to cancel it. Once you've canceled it, there is a place where you are being told to activate Inspector. So you will activate it by clicking on the hamburger, activate. Once you've activated, it will bring you here. And for the lab specifically, we are looking at Lambda functions. You'll learn about Lambda functions later. Lambda functions are normally used for event-driven. They're mostly used in event-driven architectures, and you'll get also to learn about what event-driven architectures are, or serverless architectures. So that is something that you will learn. So you see, we can use it. We can use this for different purposes. Amazon Inspector to scan by vulnerabilities, by instance, by container image, by container repository, by Lambda function. So already from here, you can see what Inspector can be used to scan. So it can be used for ECR containers. This is Elastic Container Registry. Yeah, Elastic, is it? Yeah, Elastic Container Registry, ECR, Elastic Compute Cloud instances, EC2, Lambda functions, and code repositories. You know, all of this. So you see, this is like a dashboard of which when you log in, it already shows you. You see, like here, it's already scanning our Lambda functions, because it's only the Lambda functions that are running in this lab. So it has scanned them. 100%. And then we have no code repositories to scan, no container repositories to scan, no instances to scan. If we had those, and no container repositories, also no code repositories. So if we had all of this, then you will see some metrics here. So if you have a problem, it will show you here. It gives you a high level overview where you can actually see in my workloads, I have problems in my ECR containers. So I need to focus my attention there, go and remediate the problem that is there. You understand? So that I can go there and remediate the problem that is there. You see, so this is just a very nice overview, a very nice thingy that you can actually use to check the health of what is being scanned by Amazon Inspector. The work of an inspector, the normal inspector that be it city council inspector, be it a police inspector, what they do, their work is to investigate. So it checks to make sure that people are not breaking a rule. So here is also to check to make sure that your workloads in the cloud, but when I talk about workloads, I mean the likes of Lambda functions, EC2 instances, containers, repositories, in your AWS environment, all of them are healthy and they are performing as they should. So let's go back. We'll revisit that. So where were we? So we were saying that this one, when you're using it to check network exposure for your EC2, first thing, it will help you find ports that are reachable on the instance, Inspector Mwala, okay? It assigns a severity level to a potential exposure based on predefined best practices rules. So when you're talking about severity, we have high, medium, critical, low, you understand? And then it highlights network configurations that are overly permissive. It tells you if you have given, for example, if your network configurations are overly permissive. Remember what we said, close all doors, close all ports that are not being used. So for example here, so we have a find on instance ID. That's the instance ID you see on TCP port 23, which is associated with telnet, is reachable from the internet. So this is the finding, that on this instance, TCP port 23 that is associated with telnet is reachable from the internet. And the severity for this is high. So what is the description? On this instance, TCP23, which is associated with telnet, is reachable from the internet. You can install the inspector agent on the instance and rerun the assessment to check for any processes listening on this port. So there is something we call an inspector agent that you can now install. Remember, an instance is just like your computer, which you can install things to. And then the instance with that ID is located on VPC. You're even given the VPC ID and has an attached elastic network interface, ENI, of that, which uses network access control list. So we have our NACL. The port is reachable from the internet through security group. So even the security group and the internet gateway are given. So when you sit down and you start looking at these things, you'll be able to see. You are told that this one is connected to internet gateway. If it's connected to internet gateway, it already tells you that this instance in itself is actually located inside a public subnet. You've been given the VPC ID. So you are able to find, if you have multiple VPCs, you can actually go straight to that VPC and find that instance. Then what is the recommendation? So a recommendation that you're given is what you can use to remediate the issue. You can use the recommendation to remediate the issue. So you are told you need to go and edit your security group, and you've been given the security group ID to remove access from the internet on port 23. You see, so you just go to your security group on that instance and do exactly what you've been told. And then when you rerun the scan, it will show you that that issue has been resolved. You understand? That issue has been resolved. So that is how we protect our workloads on the cloud, by using Amazon Inspector. And what you see here in terms of these notes is just a repeat of what we've talked about. So the recommendation is to change the instance security configuration to close port 23. So for our lab, we'll not be doing something to do with EC2. We'll be doing something to do with Lambda. We will be trying to remediate an issue that the inspector has flagged concerning Lambda. And you'll see what I mean by running the scan and resolving the issue. So we'll see that. Then Other network discovery countermeasures. So these are some other countermeasures that you can do in addition to what we've talked about. So monitor the network for suspicious activities. You need to record the traffic that is entering the network, watch for unknown IP addresses, and monitor for ports that are being scanned sequentially. Monitor for ports that are being scanned sequentially, because when a threat actor is trying to hit a system, they are likely to scan ports one after the other. So it's possible for you to find them maybe trying to scan port 3323, then 3324, then 3325. So it's like they are trying. It's like you have this many keys and you're trying this one to open the door, this other one to open the door. And the keys that you're using, if you look at how they look like, those keys, all of them, the first thing that they need to do, they need to be able to enter into that keyhole. You'll not just use a key that is not fit for that. So that's why we are talking about monitoring ports that are being scanned sequentially. So sequentially is the same way that you will use keys that look almost similar, but there's that distinct thing that makes one key stand out from the rest and can now open that door. So you need to be careful about that, even when it comes to our network discovery recommendations. Then you also need to limit remote administration access. You limit protocols that are used for remote administration, things like SSH, RDP. You need to limit them and only allow them to people who are authorized. Then also limit locations from where remote administration can be done. Yes, you can actually define that in your runbooks. You can define that in your operating procedures to say that, for example, if you want to access our systems remotely, you can only maybe access them from this particular place or this particular region or this particular institution or stuff like that. Then you can also implement an authentication, authorization, and accounting policy to limit who can access network devices. So remember, we talked about authentication. Authentication gives you access in. Authorization tells you what you can do when you're in. Accounting / auditing is used to check who did what where. Who did what where, because you can have so many people who are authorized to do different things within the network, but now you need to have an accounting / auditing policy that allows you to know of these people that were authorized to do this, who did what, because sometimes people mess up in a system and you need to find the culpable person. So the same things that we've discussed above are highlighted here, like who is permitted to have administrative access, how is the device, how the devices are accessed, for example, which protocols can be used, then where the device are accessed from. For example, remote administration from internet is strictly prohibited. So everything that we discussed above, you can actually come and interact with it from the notes. Then we continue and talk about network. Let me see, what is the time? 10:30. At 10:03, at 10:30, 10:03. 10:03 is still good. We are still good on time. So network architecture hardening. So we are now talking about hardening our network architecture. A network architecture hardening increases the security of a network through design improvements. Through design improvements. So when we are talking about architecture, remember the other time when I gave you a test of how a network architecture looks like. When you are trying to architect, you're trying to say this service, we want it in public subnet, this one we want it in private, then we want to have an internet gateway here, we want to have route tables there, all that's just an architecture. So we are talking about your network, and your network also needs to have an architecture. So what do we mean when we are talking about network architecture hardening? So network architecture hardening increases the security of a network through design improvement. So you are improving how your workloads have been architected, or how the different components of your system connect to each other. So when talking about network architecture hardening, this can be achieved through the following. One is by adding security components to the network. So adding security components, things like network firewalls and intrusion prevention systems. So in our normal machine, say you're on Windows, we have firewalls that come by default with our Windows OS. We have Windows Defender, which is a firewall. Okay. Then for intrusion prevention systems, some people use things like antiviruses. antiviruses and and anti-malwares and antiviruses. What are some examples? People on Windows or anybody else, what are some of, give me some examples of antiviruses that you know or you've used. There is one that I'm looking for. There's one that I'm looking for. Antiviruses, anti-malwares, Kaspersky. Hey, and you've just given me the one that I was looking for immediately. Kaspersky. Back in the day, many years ago, many years ago, we used to go and download Kaspersky updates on a flash and come and update our systems. Huh? Yeah, that's what we used to do many years ago, and even organizations used to do that. So for those guys that buy, okay, not organizations, that was mostly for individuals because organizations could afford to buy licenses. Some of us, we were using, I'm lagging. Oh, yeah. 1 second. Give it a second. Give it a second. Yeah, people stopped. It's true, Salem. People stopped installing antivirus programs in their PCs. Personally, I think for the many years that I've used my computers, I don't use I don't install those antiviruses because I believe what Windows gives us is sufficient, and I've been working online for a while, so I know. If I was to be attacked, I would have been attacked by now, but all is good. Gideon, I hope it has improved. Gideon, or anybody else, am I still lagging or am I good? I'm good. I'm good. Awesome. Thank you. Thank you, people. Thank you. Awesome. So we are talking about network hardening, and we've said one of the ways to deal with it or achieve it is to add security components to the network. So that presents in terms of network firewalls and intrusion prevention systems. And then we can also segment our network, segmenting the network by using private subnets and using network access control lists. So here we are specifically talking about the cloud. So when you are creating a private subnet, remember what we talked about when we were talking about those private subnets. We were saying that private subnets restricts access to the internet. Traffic flowing from the internet to your instances are restricted. And then, of course, network access control list also defines the deny and allow rules. It defines which type of protocol is allowed. Again, those notes are just an explanation. Let's look at network firewall briefly. A network firewall is a protection mechanism to filter incoming and outgoing traffic in a network. Incoming and outgoing traffic on a network is filtered. Even organizations use this so that they make sure that even the outgoing traffic, there are sensitive things that can be added in the. Yes, let us restart our labs kindly. Thank you, Leonard. So I was talking about organizations using this network firewall to even restrict what goes out from their systems, and even the security team will have some. They will flag some emails or some information or some data that is going out if it contains what they consider sensitive. You understand? So a network firewall allows the following: one, some packets to pass and block others based on rules such as source and destination IP addresses, source and destination port numbers, access protocol type, only authorized access inside the network. So they can do that. So they can allow some to pass, block some based on what is the IP of the source, what is the IP of the destination, what is the source and destination port number, what is the access protocol type. And at least now we can use these words with ease because we've already introduced you to those terms. And then a network firewall can be a hardware device or it can be installed on as a software. And this one you are familiar with because you've just given me examples. And then the number and placement of firewalls in your system depends on your network topology and security requirements. So here what you're trying to say is that not all networks are the same. not all networks are the same. If you have a small home network, of course, you'll have fewer numbers of firewalls and security devices or security requirements compared to a big organization like, let's say, Safaricom or AWS. You understand? Okay. Again, this one just reiterates what you've talked about. And we have an example of a firewall. Look at that. We have our corporate network. These are our web servers. Corporate network, which is a trusted intranet. So these can communicate within themselves. Now, when they want to connect to the internet, the port that is opened for them is port 80, which now allows HTTP traffic. But even this goes through what we call a network firewall. And then this network firewall, the packets that are allowed into the system defined by the network firewall is what? Is traffic through port 80. You see now traffic from port 22 is blocked because it is not allowed by the network firewall. So we have this public network, which is untrusted. The internet is always untrusted. So when you're architecting for your network security, always remember that the internet is not to be trusted, and you have to have multiple layers of security to protect your corporate network. Okay, that is very, very important. Very, very important. So, network firewall best practices. When configuring the firewall, consider the following. Start by explicitly denying all traffic, then permit only needed traffic. Deny all, only permit what is needed. Why are we denying all? We are denying all because I've told you that when you are working as a security person in an organization, always distrust the internet. Always distrust the internet. That is like the first step that you have to do. There is something in security that we are taught a principle called zero trust policy. And this is not just for the internet, but it is generally when you are coming up with security measures to protect an organization, start with a zero trust policy. What is zero trust policy? Zero trust policy simply says you trust no one. You don't even trust yourself. You don't trust the organization, people working in the organization. You don't trust the other stakeholders. You don't trust the internet. So by operating with this principle, and this is for security, doesn't mean for general business operations. Of course, you need to trust people. But now when you are trying to give access and you are starting from a level of zero trust, then you will start trusting people gradually by giving people permissions to only what they need. You understand? So zero trust works very, very closely with the least privilege principle, which also states that you only give access to people for what they need to do their work. For instance, if it's accountants, you give them permission to access the part of your network that only allows them to do their work, similar to HR, similar to devs, because you will discover that these different groups of people or users, these different groups of users have different requirements to do their work. So you only give them access to what they can do. Giving too much permission can actually expose your network to and actually the entire corporate network to what? To vulnerabilities. So that's very, very important. Then number two, block traffic that is directed to network control devices unless this traffic originates from a trusted network. You understand? And we've already said that the public network, which is the internet, stands out as a distrusted network. It is not trusted. So you only allow traffic into your network control devices that are coming from trusted sources. So you see, what makes us to work comfortably with, even in our VPCs, to work comfortably with traffic that's coming from the internet is because we have that internet gateway. And later on, you will learn that the internet gateway is not just a device that works as a standalone. It also incorporates other security services that now works like a network filter, a network firewall of sorts. First of all, to sniff and scan the network before it is allowed into the VPC. So this service that does that is called WAF. WAF, what is that? What is WAF in full? Web what firewall? Let me see. WAF, AWS. WAF is called web. Web application firewall, yes, web application firewall. So this is a cloud-based service, and you'll get to interact with it later. But it's a cloud-based service that protects web applications from common exploits and bots by inspecting, okay, and filtering HTTP requests based on custom or managed rules. So you write your rules, or you use rules that have already been written for you by AWS to filter and inspect HTTP requests. You know, most traffic that comes into our VPCs, it comes via that protocol HTTP. So it sniffs, it inspects, it filters, and then allows based on those rules. Okay, good. Then we have also log all exceptions. So it's also important to you to log all exceptions. So when you're logging exceptions, it means that you write down through again your rules that says allow all this traffic except this. So whatever has been allowed or disallowed is logged. To log is to record. Then another best practice is place the firewall as close to the traffic source as possible. So you don't put the firewall far from the traffic source. You put it close to the traffic source so that it filters and inspects that traffic close to that source. You know, so things like internet boundary. When you're talking about internet boundary, for instance, for our workloads, our boundary will be the VPC. You know, it will be the VPC. So you place your firewall there. The WAF will be there. Okay, and by the way, this is also an examinable question. You'll be asked what is the use case for WAF. You know, what's the use case for WAF? And sometimes you'll see them even ask you combination of internet gateway. It needs a security service. So if it needs a security service, I've already given you a hint or an answer to that question. It is the web application firewall. Then we also have internet network segment boundary, and those boundaries, we've talked about them. The boundaries are the likes of subnets. Okay, then you can also supplement your network firewalls with the application firewalls, just the way we've talked about web application firewall is one of those firewalls that you can use. And then, of course, the notes there are for your consumption. Then we talk about the next best practice. So in our next best practice, let us talk about yes, so you can use firewalls to create different network zones with different levels of security protocols. You know, different levels of security protocols. And a network zone is a portion of a network with specific security properties. And when you think about a network zone, just think about subnets. It's the easiest way to think about it when you're in the cloud. So think about it that way. So different subnets will have different rules that allow different types of traffic to come in or get out. You know, and sometimes you can even go deeper and even think of a network zone, maybe even as security groups. Security groups can also be used as an inner layer to protect now your instances. You know, your instances are now protected. I know it is in the security groups that we also define what is allowed in and what is allowed out, you know, stuff like that. Then you place network resources in the appropriate zone based on their security needs. So your network resources can be your EC2 instances, for example. If you have an EC2 instance that you need it to access the public internet or to be accessed from the internet directly, throw that one in a public subnet. But if you have this workload, let's say you have a database server that you don't want it to be accessed by your users directly, you can now hide it inside what? Inside a private subnet. That is very, very important. Now, let me see how we are doing on time. So it's now 10:20, I believe. It's now 10:20. 10:20, what I need you guys to do, I need you guys to take a break. And it's going to be a short break, sorry. It's going to be a short break. I'm not going to give you a very long break because we have quite to cover. I want us to finish this and then do the lab in class. Do the lab in class because it's a short lab. Do that lab in class and then see if we can start on security or on systems hardening. See if we can start on systems hardening. But for now, I want you guys to take a break. I'm going to give you guys a 20-minute break. Yes, let's be back here at 10:40 sharp. If you come late, you'll find us moving. 10:40 sharp. If you had not taken breakfast, please take your breakfast. If you need to stretch, please stretch. Let's meet back here at 10:40 on the dot. Cool? Okay. Cool. Awesome. Awesome. So, so we've been talking about security since morning, and now we are going to continue. And now we are getting into the depth of what AWS has to offer in terms of security services and resources. And I mentioned WAF or WAF in passing. I mentioned NACLs or knuckles also in passing, but we've talked about knuckles before, so it's not something that you guys don't know. And then now I want us to look at AWS security groups. So when you're talking about security groups, say that in the AWS cloud, a security group implements a firewall to protect our EC2 instances, So our EC2 instances are protected using what we call what? Security groups. And you guys have had an opportunity even to use security groups in the labs. So security groups, what are they and what do they do? So for security groups, you say that they act like a built-in firewall for instances, and they are associated with network interfaces on an instance. So this is important, and this one normally comes in exams. So you need to know that security groups are used to define rules that determine the access to an instance. And by access, we mean you are able to define what we call inbound traffic rules and outbound traffic rules. So remember, inbound is what comes in. Outbound is what goes out. So you are able to define those two. And they are stateful in nature. Don't worry about the term stateful. You'll meet it again. And then for security groups, security group rules are based on the following three key metrics. Number one is protocol. And by protocol, you've seen us define protocol when we are defining these rules in terms of which protocol are we going to allow? Which traffic traveling through via which protocol are we going to allow to our instances or from our instances? And by this protocol, I mean the likes of SSH, HTTP, and HTTPS. Those are like the main ones. And then, and of course, all of them are TCP. And then we have port number. Port number, you remember I asked you in the previous session, what is the port number for that allows for SSH? You told me it is port number 22. We know that port number 80 is for HTTP and port number 443 is for HTTPS. And then in addition, we also learned that, though in passing, that port 21 is for telnet. Port 21 is for telnet. And as I've promised, we will get you guys a chart that shows you port numbers versus the kind of traffic that they allow into our workloads, even for your future reference. Awesome. Then, of course, we've talked about the fact that you can control access to an instance by configuring your security group rule, as we've done in the previous labs. And then you define these rules that allow inbound or outbound traffic. You cannot define, listen, you cannot define deny rules. Rules are based on protocol. Rules are based on protocol. So you are only allowed to define allow rules because deny, explicit deny is, okay, traffic denial is explicitly done for you. So you don't need to define deny for your SGs. You just say, because when you are starting with a security group, all traffic is denied by default. So it is you to say, yes, all is denied, but now I want to override that by saying, deny all but allow, say SSH. Deny all but allow SSH and HTTP. Deny all but allow SSH, HTTP, and HTTPS. I hope that one makes sense. Then, of course, we say that rules are based on port number, protocol, source or destination IP, or address of the traffic. Then, now, when we talked about stateful, if you allow a certain type of traffic into an instance, the same traffic is allowed out of the instance. So if you allow inbound traffic let's say SSH port 22, the same traffic is also allowed out. These rules apply regardless of any outbound rules. So note that the stateful nature of security groups means that if you allow a certain traffic into an instance, the same traffic is allowed by default out of the instance. And this rule applies regardless of any outbound rules. Conversely, if a particular instance is allowed out of an instance, it is also allowed into an instance regardless of any inbound rules. And that one makes it so easy for us when it comes to defining these rules, because you don't need to concern yourself that now that I've allowed HTTP in, where am I supposed to go and also set HTTP out? You understand? So the diagram in this slide shows an instance protected by a security group. Of course, you know what security group does. It filters all traffic that is coming into and out of the instance based on the rules that you have set. For instance, look at that. We have HTTPS. This is traffic that is coming from the internet client. And then you have your security group. You have your instance in here. So you can see how traffic is flowing. And now you see source is from the internet. This is 000/0, and then the ports allowed is port 80 for HTTP and port 443 for HTTPS. The rule here is to say allowed. We've allowed intranet IP address, okay, and we've also allowed it on port what? SSH. We have allowed SSH traffic on port 22. So we have two rules for this particular security group. One is which allows traffic from the internet, and another one also allows what? SSH traffic. Okay, I hope that one makes sense. Then in the application tier instance, we have rule 1, where the source is the web tier for port 443. Then rule 2, this one also allows for what? SSH and RDP. You see now the port for RDP is 3389. So if I asked you tomorrow or in the afternoon, what is the port that allows for RDP traffic? Remember, it's 3389. Similarly, for this other one, you see what it does. So we have like 3 levels. We have a web tier, an application tier, and a database tier. So, sorry. So when you are architecting, it's very possible for you to call this one a 3-tier architecture. 3-tier architecture, because you can see it has 3 tiers: tier 1, tier 2, and tier 3. Web, application, and database. All right? All right. Okay, cool. So that is good. That's good. So the explanation is as you've seen there. So it does the same thing. So remember, 3389 allows for what? It allows for RDP traffic, especially if you're working with Windows instances. Next, we talk about intrusion prevention system, or IPS. We say that an IPS actively protects a network against threats. So the work of an IPS is to actively protect a network against threats. And we say monitor. It serves to monitor network traffic, detect threat, and automatically defend against them. You know, it does not just monitor and detect, it also defends against them. Then it uses different types of threat detection mechanisms that include anomaly-based detection. By anomaly, we mean that ordinarily you expect a system to operate in a certain way, but now it starts operates in a different way. So that will be flagged as an anomaly, and it will detect that and find a way to remediate that situation. Signature-based detection. Signature-based detection is that sometimes when you are using certain services, they come with certificates that are signed. If the signature on that certificate is not what the server, for example, expects, then it will flag that and it will find the root cause and remediate. You understand? Then it can be a hardware or a software solution. That IPS can either be a hardware or a software solution, and it's usually placed behind a network firewall. So when we're talking about WAF, if you want to implement an IPS in the cloud, you will put this IPS after the network firewall. So the network firewall will first filter the traffic, then the traffic that reaches you in your IPS will then go through another level of scanning. So for instance, look at that picture that we have there. We have our corporate network, which is our intranet, and we have the public network, and then you have an attacker out there. So that attacker is trying to send packets to server 1. Now it comes through network firewall. Maybe it penetrates through the network firewall. it gets through the network firewall. And if it gets through the network firewall, it gets the intrusion prevention system. The intrusion prevention system reads the packets and then discovers that either they don't have the right signature or they have anomalies. Now, the number of HTTP requests to a server 1 is above expected rate. That's actually an anomaly. So maybe you have executed or you have implemented what we call rate limiting, where you've defined the number of requests to server 1 that you normally expect. And then now you start seeing that this number has gone, it has even 10 times or even 100 times itself. So you'll be able to flag that. Rather, the IPS will be able to flag that, and then that exploration will be captured at that place, and now it will not reach your server. I hope that one makes sense. That one makes sense. So, sorry. For anomaly-based detection, we said the IPS compares the traffic patterns against the established baselines for any deviation, like what we've just said about the number of packets or requests that we expect from server 1. If it goes way above, then there's a possibility maybe it might even be a DOS or a DDoS attack. Then signature-based detection, the IPS monitors and analyzes the traffic for known patterns or attack because it references what is available, and then it is able to see and say, for example, here we have a problem. And I like what we have here. Furthermore, it sees the requests are coming from the same source. Because this pattern matches a denial of service attack, the IPS blocks all requests from the source to protect the network and the server. So I hope that one makes sense. Now, IPS, AWS Network Firewall. So the IPS feature of AWS Network Firewall inspects traffic flow to protect a network from vulnerability exploits. So this provides network protection for virtual private cloud, VPC, on AWS. It defines the criteria for inspecting and handling traffic in rules. Then it uses signature-based detection engine, and we've talked about what signature is. So you see, like here we have our sources from the internet, the destination is back to the internet, and the type of protocol is ICMP, priority 5 and priority 10. And then you have all, meaning all protocols from the internet and to the internet. So the action here is, if it's ICMP, drop it. If it is from all, you can forward it now, forwarding to the relevant place. Okay? So here we are told you use rules to define criteria used for inspecting traffic and for handling packets and traffic flows that match the inspection criteria. For example, you can choose to drop or pass a packet or all packets in a traffic flow based on the inspection criteria. The slide above shows an example screen capture of how to edit a rule in Amazon VPC management console. Notice how a rule was created to drop all ICMP traffic in the VPC. And you can see, and we say the reason why you drop this is because you're trying to prevent attackers from using that protocol. Okay. Next, let's talk about segmenting a network. Segmenting a network almost sounds like segmenting, but segmenting a network. Now, you have this network. We know that our VPC represents our network, right? So now that our VPC represents the network, you can actually segment your network to ensure that your workloads are protected. Okay? To ensure that your workloads are protected. So you can use network segmentation to apply different security controls to different parts of your network. You know, like what you saw us do when you are doing public subnet versus private subnet. So segmenting creates multiple smaller logical networks from a large network, e.g., for instance, here we are talking about each logical network is called a subnet. That's what I've just talked about when I was talking about private versus public subnet. And then each subnet is assigned a contiguous subnet of the IP address of the large network. And you did that when you were doing IP subnetting, where you saw that you are taking the big CIDR range of the VPC, and then we come down and now pick a smaller range for our subnets. Then each subnet can be configured with its own security controls to meet the requirements of different types of resources in the network. For instance, for public subnets, you can put your instance there and allow it access to the internet. But for databases which do not need to be accessed directly by clients. You can put it in a private subnet and deny access to the internet, save only for when it is trying to get updates and patches, just to patch itself and make sure that it is protected from any vulnerabilities. So that is very, very possible. And then we are also talking about CIDR notation, where we are saying it is used to specify subnet IP address ranges, which I've just mentioned. This notation provides a shorthand of describing the size of a network. Remember the /16s, the /18s, the /26, the /28, the /24, all that is used to tell you how many IPs can be assigned to that particular network or subnetwork. Okay, I hope that one makes sense. Then we also talk about other benefits of segmentation that include it gives you, it makes your work easy when it comes to managing that network or that subnetwork, because you know that if you are dealing with this particular subnetwork, you can just zero into it. If it has a problem, you can deal with it as it is. And then it also helps in improving network performance. Again, just read through these notes. There is nothing there that I want to reiterate, but if you read it, we'll just re-explain what I've just talked about. So here's an example. Here is an example of subnetting. I want us to start from the internet. We go through a firewall. There's a perimeter zone. And someone had asked, what is the difference between firewall and DMZ and a DMZ zone? Anyone with an idea? I was to research it, then I forgot. What is the difference between a DMZ and a firewall when you're talking about network security? Somebody? Anyone? I'm checking the chat to see. Salem is reminding us that we have 2 months remaining to 2026. I think this was triggered by the motivation that I had playing for you guys during the break. But always remember this, and I will remind you this because it is a mantra that I live by. It's never too late to be what you might have been. Don't forget that. It is never too late to be what you might have been. So if there's a better way to start now. Don't be that person that is waiting for January, maybe to start living right, maybe to start working out, maybe to start pushing yourself in terms of chasing after your dreams. I'm still waiting for my answer. You guys, you have the freedom of Googling. Google and get me the answer. What is the difference between, and here was the question. Where is it? Yes, it was asked by Rich. What's the difference between firewalls and DMZs? Yes, someone find me that answer. Are you guys in class? I've asked a simple question, and I've even given you the opportunity to Google. Justin, are you in class? Or am I talking to myself? There's always that.
I'm in class.
Mbona mniambie the difference between DMZ and firewall? And you don't need even to say it from your head. You can Google. Someone Google and paste it there. Musembi, what's happening today? You are our official Googler. Good. Here I see. DMZ is a network segment that is intended to provide controlled access to resources from untrusted networks such as internet, while minimizing risk to the internal network. A firewall is a security device or piece of software that serves as a barrier between two networks, most commonly an internal network and an internet. So you can, so from this description, I guess you can actually have a DMZ. Okay, from the internet, you do a DMZ, and then from the DMZ, you put a firewall. You know, you put a firewall. DMZ is a separate network zone that sits between your private internal network and public. Firewall is like a security gatekeeper. It filters traffic coming in and going out of the network device. Sorry. Firewall is for security device software. DMZ is a network segment. Okay. Yeah, you've decided to be a follower today, Daniel. Eh? I hope you've not gone to a function where you don't want to talk. Okay, cool. Okay, be a follower, be a follower. Be a follower. It's good. You've actually been participating a lot in the class, and we really appreciate your participation. Ivy, thank you for this. A firewall controls and filters network traffic for security, while a DMZ is a separate network area that safely exposes public service without giving direct access to the internal network. Awesome. That was a good question, Rich. I hope you have gotten the difference. So look at this. Look at what we have. So we have our perimeter zone here, and then we have our intranet zone. So in our internet zone, we have a router. We have our firewall, then we have our router. So this router on the cloud, this can be on. Someone is saying something? Juliet, you are unmuted. Chunga usibant. Okay, awesome, cool. So we have our router, okay? So this router is what we see in our VPC as the internet gateway. This can be our WAF. Then we have our network ACL with this firewall, okay? Let me see if there is someone saying something. No, you'll need to Google that. Hata mwenye, okay, nimesikia DMZ kutoka kwako, though I've had it before, but I haven't really taken interest in it in as much as I'm into security. So just Google, engage Kuzo. Kuzo will tell you a bit of some things. In fact, you can even tell Kuzo to explain to you like a newbie or even a 5-year-old. By Kuzo, I mean ChatGPT or Grok, whichever AI that you guys use. It will explain to you very, very well. And it will even give you examples, okay? I would have done that, but I'm pressed for time. And I'm also on one device. Power Manenos this side, but we are still carrying on. So, but should you not have found an answer by end of class, I'll find you a simpler explanation. Don't worry, Rich. But thank you for your answer. Thank you for your question, and thank you for always asking questions. That's very good. So I want to minimize this thing. Cool. So now you see we have this. This is now what we call a two-tier architecture, where you see we have our servers, we have our printers, all of these are in the intranet, and then we have our network access control list there. We have another network access control list down here. So these two networks can communicate to each other. Okay, so we have a HR subnet and we have a website subnet. You can see their IP addresses. Both of them are /24. One of them is .10, another one is .20. So there is no overlap. Okay, and then of course you can see now here we have a website application server and a website database server. And when you drill in, you'll figure out that this website application server might be in a public subnet, and then this database server might now be in what? It might be in what we call private subnet. And you can also see our CIDR range is a /16, but it is 192.168.0.0. This is our VPC. If this is in the cloud, this is our VPC CIDR range. Okay. So everything that I've talked about is explained there about overlapping, overlapping of those. Everything is explained there for your own benefit. Please read through those notes. And then we have NACL. Apart from subnets, we also have NACL. I normally call them NACLs, but you can call them network ACLs, still the same thing, as long as you know what they do. So we have been told that network access control lists act like a firewall. They also act like what? Like a firewall. In the AWS cloud, this is used to protect a subnet. Now, difference between NACL and security group is that security groups are used to protect instances, while knuckles are used to protect what? A subnet. So knuckle is at the subnet level. It's associated with the subnet, when security groups are associated with what? They are associated with our instances. Always remember that difference. So a network ACL filters inbound and outbound network traffic and is typically implemented in a switch or router. You know, it is implemented in a switch or a router. And remember, when we are mapping these things that we find on-prem versus what we find in the cloud, we said that our switch is like the subnet that you'll find in the cloud. So it filters inbound and outbound network traffic and is typically implemented in a switch or a subnet level. And it is stateless. It is stateless. And you'll get to know what we mean by stateless. Remember, we said security groups are stateful. So stateless versus stateful. That's another difference between network access control list and security groups. You know, apart from them securing different levels of our network, one is for instances, another one is for our subnets. Another difference there is that they are both what? Okay, one of them is stateful, another one is stateless. That's the difference. You know, in the AWS cloud, a network ACL is associated with a subnet in a VPC. I said that it allows or denies in and out of traffic in and out of a subnet based on rules. And that is the meaning of stateless. So it does not mean that the fact that you've allowed in, it is automatically allowed out. Or that you've denied in, it is also denied out. You have to explicitly state it via the rule. Okay, then it hardens security as a secondary level of defense at the subnet level. Why is it a secondary level? So it is hardening security. Remember, the first security level we met is when we were coming into the VPC, where we have our internet gateway and we have a network firewall. You know, then after network firewall, the second level, we now come and meet knuckle. When we meet these knuckles, now the third level will now be what? Our security groups. I hope that one makes sense. I hope that one makes sense. So remember, stateless means you have to define both rules, okay? You have to define both rules. Like here, what you're told is a network ACL is stateless, which means that the inbound and outbound rules are independent of each other. If a type of request traffic is allowed inbound, you must explicitly define an outbound rule for the same type to allow the response traffic. So you remember, I like the fact that we introduced these terms early to you guys: request and response. So request is what you send out. Like for instance, if you're trying to access landly.com, when you type www.landly.com on your browser, that is you requesting some information from Landly. Or maybe there is a new course that you want to apply for. Then you go to landlyafrica.com/courses. Then you find your course. The course that you're looking for, maybe it's HR or data analytics. You fill that form. When you send it, what you send, that is what we call what? That's what we call a request. So you are sending a request to the server. Then once your details have been captured and placed in the database, you will get an appropriate response. You'll get an appropriate response. Similarly, also when you're in the cloud, these things happen. So the different components of our system, they send packets of data via traffic protocols, different protocols, and then they receive things back. Again, we are saying that traffic from the internet or to the internet, is normally filtered via these things that we're talking about here. So we are saying again, in the AWS cloud, a network ACL is used to protect a subnet inside a VPC. You can define, allow, and deny rules based on the protocol, port number, source, and destination IP of the traffic. So whatever you use to define is the same as what we use to define what? Security group rules. But only the difference here is we have to explicitly define, allow, or deny rules. I hope that one has made sense. So let us look at this layered security model of a VPC on AWS. Okay, so we have this layered security model that you can see here. And then we are told that network ACLs and security groups provide multiple levels of network security to protect an instance. So apart from, okay, there is one level that has not been added here. It's supposed to be somewhere here. I hope you can see my cursor. It's supposed to be somewhere here. So that's where we have the WAF, web application firewall, which gives you like the first level. Then you come and meet the network access control list at the subnet level, which gives you the second layer of protection. And then now the third layer of protection is the security group. Okay, it's security group. I remember during my time doing this course, I really had a hard time just making sense of these two layers of security, these two layers of internal security. But I hope the way we are explaining them to you guys, you are understanding. You understand, because this is very important even for your exams. Even for your exams, and also when you get out there and you start doing your own portfolio projects and even start taking in clients and even working for organizations, it's very important for you to know the 3 layers of security that is offered to us by AWS. So security level number 1, web application firewall. Number 2, network access control list. And number 3, we have security groups. And what did you say about security groups? They are stateful, meaning what? If you define, deny, or allow rules, if you define, deny, or allow for inbound, it is automatically replicated in the outbound. Yeah, but for network access control list, we've said if you define, deny, or allow for inbound, you have to go and also define, deny, or allow for outbound. I hope that one makes good sense. Okay, and you'll be doing a couple of labs in the future that will just help you to understand and make sense of this. Okay, and make sense of this. So that is okay. That is okay. That is okay. So the diagram that you see here is actually showing you how to segment your network. You have your AWS cloud, which represents your AWS account. And then remember what we said, you are allowed to have up to 5 VPCs in a region, but you can ask for quota increase. Remember that. And then we also say that you can have up to 200 subnets in a VPC, you know, in a VPC. And then I also told you that VPCs are logically isolated, meaning that whatever you have in VPC 1 cannot directly communicate with VPC 2 unless you allow them to communicate through what we call VPC peering. So remember that. Okay, cool. All right, now we come down to our checkpoint questions. And checkpoint number 1, what is network discovery vulnerability? Checkpoint question number 2, what are 2 measures that can prevent network discovery? And checkpoint question number 3, what are 2 network architecture hardening measures? Who wants to try question 1? But I've discovered that most of you guys fear. Is it fear, really? Is fear the right word? You fear to try because you think that you will be, what is it? Is it not really judged? As in, you don't want to get it wrong. Remember, when you're learning, there are no wrong answers. Any attempt is appreciated. So what do you understand by the term network discovery vulnerability? I guess, you just don't, okay, I've seen someone has written something. Let's see. Reconnaissance on a network to see points of weakness. That's a very good one. Thank you. Let's see what we've been given as an answer here. So network discovery vulnerability is a security exposure that lets an attacker discover information about a network environment, including its devices, hosts, services, and applications. The attacker can then use this information to maliciously affect the network and its resources. Okay, so how can you prevent that? We said one, you can limit remote administration access, and you can also disable or restrict the use of. Restart your labs, please. Has mine ended? Oh, okay. Mm-hmm. You know, I had already done this lab. That's why I already have a score of 1:1. 1/1. So no wahala. So you can also do it by disabling or restricting the use of network discovery protocols. You remember that where we said that the likes of you can disallow the use of the access of your VPC through ICMP. Yeah. So the following are two network architecture hardening measures. So we said the very first one is we use network firewalls, and then we can also segment our network. We can also do what? We can also segment our network. Yes, I need a lady to read this for us. Ladies, who wants to read this for us? Ladies, who wants to read this for us? Let me see your names, people. Who wants to read for us? Purity? Uko area? Are you around, Purity?
Yes.
Okay, let me remove this. Are you able to read for us?
Yeah.
Let me move this one also. Okay, please do. I hope it's clear. Okay. Read for us the key takeaways.
Network hardening. Network hardening implements configuration and architectural guidelines that provide preventive measures to protect a network infrastructure. Network mapping, port scanning, and traffic sniffing are examples of common network security threats. Network hardening techniques include the following: disabling unused protocols and securing vulnerable protocols, in particular discovery protocols, limiting remote administrative access, implementing an authentication, authorization, and accounting AAA solution, using firewalls to filter traffic closest to the source, segmenting a network into subnets. In the AWS cloud, firewalls are implemented through VPC security groups and subnet network ACLCs.
Thank you so much, Purity, for that. Thank you. That was awesome. Asante sana. Thank you. So those are our key takeaways, and that is all that I wanted us to discuss today about network hardenings. If you've enjoyed the class, if it has made sense to you, kindly react with a thumbs up. Let me see. Kindly react with a thumbs up so that I know that you guys at least have learned something. I hope you've learned something new. Yeah, where are those ones? Wait a minute. I'm not seeing your thumbs up. Let me pull this one so that I can see those thumbs up properly. Okay, cool. Okay, Purity, Justin, Gideon, I can see. Alphas, where is your thumbs up, or it has retired? I can see you guys. I can see Brian. I can see Basil. Awesome. Thank you, guys. That was nice. Awesome. So, so that was about network hardening. And one of the services that you will see being used mostly for network hardening is Inspector. In the cloud, we use Amazon Inspector. And for this lab, I just want to tell you what you are supposed to do. I'll not be in a position to do it myself for the obvious reason that I already did it. But it's a very easy lab. It's a very easy lab. So let me just go to AWS. and see if I can open it. Let me see something. Okay. So let's see. Let's see what we are having here. Okay, so we'll try that. So that is the lab that we'll be doing. Someone remind us of the number. What is this lab's number? It's lab number? Someone wrote it somewhere. 276, yes. It's lab number 276. Thank you. Thank you. So it's lab number 276. And as you can see here, what is the overview? So the title is Using Amazon Inspector for Vulnerability Assessment and Remediation. So the lab overview states that in this lab, you utilize Amazon Inspector to scan for vulnerabilities in your AWS resources, specifically AWS Lambda functions. So here we are looking at Lambda functions. And I told you guys that you need not worry about what Lambda does. We will learn about it later. So you learn how to activate Amazon Inspector, interpret the vulnerability reports, and remediate the findings. So the developers at any company, that is our case company that we are using, developers at any company are in the initial phases of building an application primarily using AWS Lambda. Throughout the development process, they need an automated security tool that not only scans for vulnerable software packages, but also scans within the code itself. You decide to utilize Amazon Inspector to fill these needs. So Amazon Inspector meets the requirements of being able to scan AWS Lambda functions by quickly responding to new deployments. It also automatically scans additional resources such as EC2 instances, Amazon ECR within any company's AWS account. Yeah, so that is our overview. The objectives for the lab include, after completing this lab, you should be able to activate Amazon Inspector, analyze and interpret vulnerability findings, and remediate the vulnerabilities found by Amazon Inspector. To remediate simply means to correct, okay? It simply means to correct. So the duration for this lab is 30 minutes, but you can even do it for less a time. And this is, you remember I told you that this, what you see here, will always repeat. This is just how you access your console. And then now task 1, we are being told that in the AWS Management Console, in the the search bar at the top, type and choose Inspector, and then open the panel on the left and choose Activate Inspector. So let me show you that. So Inspector, you'll just write here, Inspector, and you'll get Amazon Inspector and you'll click on it. When you click on Amazon Inspector, it will bring you to a page where we have our inspector, okay? And then when you are here, close everything that is here. It's not important. It's a lot, but just close it. Then when you see this feedback form, just click cancel, okay? Just click cancel. And then one of those things that you will have to do, you will check on this left side. There is a place where you can activate your inspector. Okay, you can activate your inspector. I cannot see it here because I've already activated mine. But when you click somewhere there, there'll be a place where the first option there is to activate inspector. So when you activate inspector, then it will bring you to that feedback form, which you will cancel out of. After you've canceled, it will bring you to this dashboard. So on this dashboard, you will need to wait until we have 100%. Okay, until we have 100% showing us that yes, the scans have worked well. Okay, that the scans have worked well. So that is what you will see. And remember, we are only focusing on Lambda functions. We don't have answers for these others because they have not been provisioned for us in this particular lab. Okay, so that is what you'll be doing. All right. That's what you'll be doing. And then once you've activated, okay, once you have activated, you will be able to, oh, sorry, I was not supposed to write there, but it's okay. So once you have activated, then you will be able to check under dashboard, summary, environment coverage, Lambda function should be at 100%. And this is what they mean. You come to summary, you come to dashboard, summary, environment coverage, Lambda function. And you can see it's already at what? At 100%. Okay? It's already at 100%. Now, because I have already resolved the problem that was here. There was a problem reviewing and inspecting resources. So you will go to the findings on the left and choose all findings. Okay. You will come to findings on the left. Here, your findings, you'll find it here, all findings. You see here, findings, all findings, click. When you click all findings, you will see your issues here. Yeah. You will see the issues that you need to resolve here. So these are the issues that you need to resolve. And then the next point, in fact, let me just split my screen to make our life easy. Control this. And then we pick this and bring it. No, not that one. That's a wrong one. So we pick this. Yes, and bring it to this side. Side by side. Okay. Cool. So, give me a second. I want to resolve something here. Cool. So, yeah, there we go. There we go. So you come to your findings. Yeah. So you come to where are we at? So from findings on the left, choose all findings which you have chosen. 3 rows are displayed. You see, row 1, row 2, row 3. And then they show the following details. We have severity. We see all of them are medium. We have the impacted resources. You can see them here in terms of their titles. And now we know that the impacted resource is already Lambda because that's what we are using. And then choose the radio button for choose the finding. Like, for example, we are told finding 32681. 32681 is this, and this is the radio button. You click on it. When you click it, it will open a panel containing vulnerability information. So we have all the vulnerability information here. And because this is important, I want us to read through it. So, so the request, we have the number up there. Then we are told request is a HTTP library since request 2.3.0. Request has been leaking proxy authorization headers to destination servers when redirected to an HTTPS endpoint. This is a product of how we use rebuild proxies to reattach proxy authorization headers, blah, blah, blah. What was important? This results in request forwarding proxy credential to destination servers unintentionally, allowing malicious actors to potentially exfiltrate sensitive information. This has been patched in version 2.3.0. So we are told that the current version of request that we are using, this is a Python library that we are using in this particular function, has a problem. Why? Because it gives unauthorized access. It gives unauthorized access to malicious attackers who can now use it to exfiltrate, or rather to get information that they're not supposed to get from us. So that's what you are being told here. So everything you see here, after you've chosen the button, within the information under vulnerability details, choose the section next to the vulnerability ID. So all that has been brought here. We have everything that we need here. Everything is here. Vulnerability ID is here. And then within the information panel, find the remediation section. So remediation is here. You see, this is our remediation. You see, update your installed software packages to the proposed fixed in the version and release. You are told to update it to the proposed to the proposed package, to the proposed fixed in version and release. So it has been proposed that we do what? It has been proposed that we can use a higher version, like for example, version 2.31.0. So this is what they have suggested. Then when it comes to remediating, you are told how to remediate in task 3. You see? So in this task, you analyze the finding reported by Amazon Inspector and interpret the vulnerability details. You update your Lambda functions to remediate the vulnerabilities. After updating the functions, you review the inspector findings to confirm that it has been fixed. So 3.1, they say you choose Lambda. You know, you come to this search and choose what? Choose Lambda. So we are choosing Lambda. Give it a second. Internet close the room. It's not fun. Okay. So we have Lambda. You see Lambda here. So we choose that Lambda. Then from the list of Lambda functions, they say select get request. Here we have our get request here. So we will click on it. So it will open for us this area which shows us what is working where. And then you scroll down to your code. This is how the Lambda dashboard looks like. You come to your code. Then in your code, you are supposed to choose in the Lambda function code editor's file browser. Editor. Are we at the editor? Let me see. Not that. Yeah, yes, here. So you are supposed to come and choose requirements.txt. So when you choose requirement.txt, this one, requirement.txt, you can see the version that was given here. We are told that request, we are using version 2.20.0, which we are told that it is an old version. So what are they advising? Remove the version number and equal signs from requests. So we'll remove this, the whole of this, we will remove that, okay? So that the line becomes requests only. Then the requirement.txt file tells AWS Lambda which Python package are required to run your function. When no version number is specified, not this, the latest version of the package will be installed by default. So latest version might even be later than, it might even be more current than what has been specified in the instructions, which is good because the more current the version, the better. Then after we have done that, we come and click on deploy. This one here, we click on deploy. When you click deploy, what it will do, it is going to execute the change that we have just implemented. See here, updating the function, successfully updated the function get request. So that has happened. Then on AWS console in the search box, let us go back to our inspector. So we go to inspector. This is Amazon Inspector. So you see, this is what I was telling you. You might be asked to activate inspector. You know, I'm wondering why it is telling us to activate again, yet we were just from there and it was working. But let us see, that was an error. So we are back here. And then in the navigator panel at the left of the page, under findings, choose all findings. So just cancel that, then come to all findings. All findings. Then under all findings, here we go. We are in the all findings place. Good. Sorry? Bashir?
Sorry.
Okay.
Sorry.
Okay, cool. So we are at the all findings. So we are back to all findings. Give me a second. So this thing is small. Okay, so we are at the all findings. We are at the all findings place here, and then they are telling us in the findings dashboard under finding status, change the selection to from active to closed. So we change from active to what is already closed, cases that have been closed, and then we look for our case 32681. So 32681 is here. You see, 32681 is here, and it is one of the closed cases. So when you see that a case that was previously opened has now been closed, it means that the issue it had has been resolved. Okay, the issue it had has been resolved. And if you come down here, you will see that everything is okay. Everything is okay. So that is that. And then in the navigation panel on the left of the page, under resources coverage, choose Lambda function. So we come here, resource coverage, you see, Lambda function. When we click on a Lambda function, if needed, expand the width of the last scanned column. So where do we have the last scanned column? Let me just read this so that I can make it bigger. Okay, so let's open this. Let's see. So we have scanning. We have all that are being scanned. Okay, and then code scanning. We don't have any code that has been scanned. But now our scanning, you can see we had like two scans, two that are currently being scanned. Okay, the AWS account is the same. This is Python. That is the same. Let me see if I can go. Yeah, here it is. Get request, because this is what we have just done what we've just updated, and we found that we resolved the error that it had. And you can see there are no findings. So it will only show you findings if it has errors. Okay, it will only show you findings if it has errors. So it is still being actively monitored. Should it develop any errors, those errors will be captured. And then once you are done there, always remember to submit your lab before. Always submit before, where is that one? Always submit before you do what? Always submit before you are now able to end the lab. Submit before you end the lab. So that was all when it came to network hardening, and that is the lab. You see, the lab is very short, and the lab is not something that should really trouble you, because it's very easy to do. I hope that one makes sense. The lab is short and it's very easy to do. Okay. Okay, so if you have followed through the lab and you understand and you feel that you can do it, let me see some thumbs up. If you feel that you can do that lab, let me see some thumbs up, please. Thank you, Basil. Thank you, Brian. Thank you. Thank you, Frank. Thank you, Elvas. Thank you, Brian, again. Thank you, Gail. I almost asked where are the girl children. Is Sharon around today? Thank you, Rich. Okay. Cool. I can see you people. Thank you, Mohammed. So please go and do that lab. It's very short and it's very interesting. So that is just part of the things that we do. And you'll discover that when you're doing labs that have to do with the AWS, you'll not be doing a lot of heavy lifting, like the way we were doing Linux, you know. I hope that one excites you. Okay. So, having said that, let me see how we are doing on time. Now, the reason why we normally prefer teaching this units side by side, network hardening and systems hardening, is because they borrow a lot of similarities, or rather a lot of content. They are kind of related, you know. They're kind of related. So you will see you will see some level of how do you call it? You'll see some overlaps. Yeah, simply put, you'll see some overlaps here. So let me move that one to my secondary screen so that I can see you guys well when you're engaging with me. Cool. So that's on my secondary screen. Yeah. All right. Super. So now, next we are moving to system hardening. After network hardening, we are now looking at system hardening. And under system hardening, these are just some objectives that we need to cover. It's a very short course and you will enjoy it, I'm sure. So what will you learn? So at the core of this lesson, you will learn how to explain the principles of systems hardening and how it is applied to computer security. That's the first objective. The next objective will be about describing baselines and explain why they are important. Okay. Then number 3, you will also learn how to harden different systems and techniques that are used to achieve that. Okay. And then you'll also be able to identify the tools that are used to detect and show common security configuration problems, the tools that we use. Okay, cool. So that's what we will be doing. Now, let us start on systems hardening. Now, we say that system hardening is the action of securing computer systems to protect them from attacks. We are from network hardening. So network, that one protects the network. Now here we are talking about the computer system. And you know, yes, the network is part of the system, but now here we are talking about now the system, now the bigger part of our computer infrastructure. So what are the goals? What are the goals of hardening? One is to reduce the number of running services, or rather, we are talking about measures that you can take to achieve system hardening. Firstly, we say that you can reduce the number of running services on a system. Number 2, you can use tools to accomplish systems hardening. And number 3, you can secure computing with the goal of making them hack-proof. So we want to make sure that our systems are what? Are hack-proof. And as you can see here, a hardened system is one that balances security and productivity. You don't overdo one at the expense of the other, because in some instances, you might find that people are trying to over-secure, and then that one now affects productivity, or they focus too much on productivity to the extent that they give security a second thought, or it becomes something that they think about as an afterthought, but that should not be the case. It is possible to have a system that is both secure and productive, or secure and efficient. So when you are architecting or when you are designing systems, make sure that you bake in security from the get-go. There is this principle that we call shifting security to the left. So when you are shifting security to the left, it means you are taking security from the end of the SDLC and bringing it to the very beginning, so that even when you are doing your requirement gathering, the first steps of SDLC, when you are doing that, you will ask, yes, you want us to achieve A, B, C, D. Now, these things that you want us to achieve, how can we achieve them in a secure way, such that we don't overexpose the system or the infrastructure to possible future vulnerabilities or attacks? I hope that one makes sense. Okay? I hope that one makes sense. So, for many businesses around the world, cyber attacks are a constant threat, and I agree with you, Salem. Overhardening can also affect user experience. That's very true. So we are saying for many businesses around the world, cyber attacks are a constant threat that businesses have tried to attempt at all to avoid. Try to avoid at all costs. So businesses must be hyper vigilant, very careful about how they secure their endpoints, which include their servers and their workstations. To decrease vulnerabilities, you must secure your systems. So the hardening process entails reducing the number of running services on a system. Having fewer running services decreases the potential of a security event. Similar to what we were talking about ports, when you are saying that the fewer ports you are opened, the fewer chances you have of being hacked or letting in bad actors or allowing bad traffic into your system. So here, when you have fewer services running on your system, this one will reduce the potential of a security event, because sometimes if you have multiple services that are running in your system, and yet these services are not important to you, a threat actor can also camouflage and use one of those services and then attack you. And here we are talking about organizations specifically, because they have a lot to lose, really. So system hardening can be a bigger challenge now. Can be a bigger challenge now as more devices move outside secure office environments, especially now that we even have this bring your own devices to work. We also have this remote work kind of a setup where people can now work from home but still access organizational resources through the corporate network. You see, that's very, very important. Logging into sensitive corporate assets through unsecure devices can lead to higher risk. For example, I remember there's a time I gave you an example where I was saying that maybe you've decided you are working with organization XYZ, and now you've decided that for that day you're not going to the office, for that day you're going to work from a cafe, and then woe unto you, you decide to use their unsecured network, and around that network there was someone that was waylaying and waiting for you to check in so that they can log into your device and cause you problems. So you see stuff like that. So that is very, very important for you to note. You should not be logging into your corporate network, either using unsecured devices or using unsecured internet service providers or Wi-Fi's. So some companies, especially, by the way, vitu za bwerere si mzuri. Freebies are not good. You go to a place and then you get that there is this free network, free Wi-Fi, where this free Wi-Fi does not even have a password. So someone can easily set up that. They can easily set up that free Wi-Fi, then allow you to log in. Once you've logged into their Wi-Fi, they'll be able to see which hosts are in that network, and then they will sniff your traffic to see what you are doing, and if it makes sense to them, they can actually launch an attack against you, or even plant something in your system that they can exploit later. So before doing that, before taking that move, and then you become a security threat to your organization, please try and think twice. Okay. Try and think twice. Yes, an example is like what Salem has given us on the chart: man-in-the-middle attack, where they can intercept your traffic. These threat actors can easily intercept your traffic. So some companies often fail to find the right balance between security and productivity, because security can diminish productivity. And I believe that is what Salem meant by mentioning over hardening. For example, it can make working remotely more challenging. You must balance hardening with the usability of the system. Don't make the lives of the people that are supposed to benefit or work with the system hard. Just and again, over hardening does not really assure you of security. It does not really assure you of security. It is like, when you hear the word over hardening, it means that you've already hardened and you've now done it in excess. And as they say, too much of something is poison. And now if you over harden, you're going to affect how your system works in the long run. And for businesses, it's not just about systems, it's about the bottom line. And the bottom line is to do with productivity or profitability. And profitability is directly connected to how easy people are able to do their work and do it well. So if you make their lives difficult for them to do their work, then downstream, rest assured that even your own profitability, the profitability of your organization, will go low. I hope that one makes good sense. So it's very important to balance between, to find a good balance between hardening with usability of any system. Okay, so I believe this was mentioned to you guys, but you're just going to look at it again in passing. We are going to look at it again in passing, the security life cycle, where we are looking at prevention as part of the security life cycle. So system hardening is part of prevention. And we have talked about network hardening and finish it. Now we're talking about system hardening. Then next you'll talk about data security, and then we'll be having public key infrastructure, or PKI, which is also part of prevention, and finally identity management before you move to detection, response, and analysis. And the way this has been arranged in that circular manner, it shows you how it flows from prevention to detection to response to analysis back to prevention. So it is an ever moving, or rather it is a continuous process that never comes to an end. You start prevent, detect, response, analyze, prevent, detect, response, analyze, prevent, detect. So if you are trying to prevent and then something comes to your mind that, yes, we are trying to prevent this, then you come to detect. Once you've detected and found out that, yes, we have these vulnerabilities, you respond to it. After you've responded, you analyzed. You see, same thing that you've done in that lab, where we first of all found that we have this problem. Once we found that we had that problem and we were not able to prevent it at the first instance. Now we detected it as a problem, and thanks to inspector found it, and it actually told us what it is and how to remediate it. So we responded by implementing those remediation. Then after that, we analyzed to see if it had been remediated, and we found that it had been remediated, which means that now we have prevented that same problem from recurring. But again, if that problem recurs, maybe because now we need a higher version of requests, then we will have to go through the whole process again. I hope that one makes some good sense. So we are told that prevention is the first line of defense. Detection occurs when prevention fails. So even for the example that we did in that lab, you saw that ordinarily we were supposed to have prevented that in the first place. But if that failed, it was detected and then it was listed, and then we had an alarm, or rather we had a notification that there is this vulnerability. And then response is describe what you do when you detect a security threat. Like, for example, we saw remediation. Remediation and response are one and the same in this example. Then an analysis completes the cycle as you identify lessons learned and implement new measures to prevent the issue from recurring again in future. So by us getting rid of the request is equal to, or rather the version of request that we needed to install in the system to be fixed. So we've made it open such that every time a new version is released, then that new version will become, so that new version will still be compatible with what we have because we've made it open. And by making it open, it means that the next time it goes to scan, it will re-update itself to the next version. So if the version that we've just installed right now is .31, then tomorrow they release at 32, it will be updated to our file without us doing anything. So we will not have that vulnerability recur. And that is the beauty of system security and network security. So you want to make sure that once you have sorted an issue, that issue is resolved, and even future instances of such an issue is protected. Future instances of that issue is also protected or avoided. I hope that one makes sense. Then in this lesson, we are told that we will learn the concept of systems hardening as part of the prevention phase, as you have just seen up there. So, authentication, authorization, and accounting. You've heard us use this term over and over, and we talked about it before. So, what is authentication? This keeps invalid users out of databases, networks, and other resources. Why? Because for you to be authenticated into any network, one thing that you need to do, you need to have what gives you access in. You need to have a key of sorts. So that key of sorts can either be a password, a username and a password, or it can be authorization tokens, authentication tokens that you use. There are certain systems that you get access to them maybe through authentication tokens. And then after you are authenticated into the system, the next step is authorization, where here we say that this it verifies that you have permission to access the requested resources. You have permission to access the requested resources. You'll discover that sometimes when you're doing a lab, or even when you're working with an organization, and then you try to access, let's say, for example, you want to access AWS Bedrock. You want to access AWS Bedrock, and then it tells you access denied. Access denied because in the permissions that you've been granted as a user, that particular service, you are not authorized to access it. You're not authorized to access it. So yes, RBAC is one. RBAC is just one of the tools that you can use to define who can access what, who can access what. And we will talk about RBAC and all those other permission parameters that can be set under what we call IAM. IAM is identity and identity access management. Identity access management. So different levels of users are allowed to access different things. So you will see how that one works. So then accounting, it gathers usage and other information that is used for auditing, and sometimes it's also used for billing. So that is the work of accounting. Cool. So those notes is just the same. So looking at physical security. So when you're talking about physical security, it is very possible for you to see the following. Physical security is essential for systems hardening. Yes, systems hardening. You know what physical security is all about? It's about who can access what. Like, for example, so yes, you might be having your systems in the cloud, but a gateway into those systems is a computer that might be on your on-prem environment. So the first level of security has to be physical, and this one you can achieve this by restricting physical access to facilities, designing building against natural or man-made disasters, and making physical security the base of all other security principles. So security has to start from, it has to really start from the physical layer. And here you can see this picture that has been provided here. We have a security person who maybe checks and who maybe monitors who is where at what time. They go around to make sure that maybe when people are off work, nobody comes in and breaks in, because some systems are so difficult to penetrate in that people have to go and get into the server room, for example, of the organization, and then plug some things and do these things or those things. And those experiences, I am borrowing them from the many movies I've watched about people trying to do those things, stuff like that. And then there's also another level where you have, let's say, an employee card or a guest card, and this card has a barcode of sorts, which allows you to get access. There's a place that I used to work where we used to have this kind of cards, where when you go, when you approach the system, it reads your card and then it opens the doors for you. So you can only access the floors that your card allows you to access. I hope that one makes sense. And then we also have cameras. As you see, we have this camera here, which also helps to monitor and check who is getting where. And you see here, they've written authorized personnel only. And then we have this card thingy here. How do you call this thing? How do you call this thing? What is the English name for this card thing? You people must be knowing it. I need to call it a dial pad, but no, it's not. So we have this, but we also have others. Okay, for this one, maybe it requires you to input a password. Then in some places, we also have those that pick your biometrics in terms of maybe your fingerprint or even your iris scan, and then now you are able to get into the system. You understand? You are able to get into the system. So physical security also contributes to system hardening. Remember that the vulnerability is at the human level in most cases. Remember what I told you? The weakest link in any security apparatus or in any network is the human component. That's why when you achieve automation, if you can achieve automation of most of the processes, you will have cut down this kind of a threat by more than half. So examples of physical security include closed circuit surveillance cameras, that is the CCTVs. We have motion or thermal alarm systems. We have security guards. We have picture IDs. We have locked and dead bolted steel doors. Another example of physical security is biometrics, which include fingerprint, voice, face, iris, hardy handwriting, and other automated methods that are used to recognize individuals. Awesome. That are used to recognize individuals. Those who write like kuku. But we're handwriting yao na kuku, same WhatsApp, you've been represented. There is handwriting for you. Okay? Okay. I'm part of that. Mimi kuandika, my handwriting is where? Okay. Cool. So types of systems that can be hardened. So these are just some of the systems that can harden. You can harden your physical security. You can harden your desktops. You can harden your servers. You can harden your applications, and you can also harden your mobile phones. So you can harden all types of systems for security, including desktop servers, mobile phones, and applications. Hardening systems eliminates or lessen attacks by patching vulnerabilities. By patching vulnerabilities. It works by turning off non-essential services, the way we said, configuring the system with security controls such as password management and file permissions, and also you get to deactivate unused network ports. So you see networks are being revisited here because networks are part of the system. Then one example is server hardening, which aims to reduce the attack surface of the server. The attack surface of the server is reduced. It's reduced by server hardening. So Where is that? Yes. So it secures the data, ports, components, functions, and permissions of a server by using advanced security measures at hardware, firmware, and software layers. Another example is software application hardening, which focuses on securing the applications that are running on a server. Examples of such applications might include a web application, a database, or other custom software. So you can also achieve that by doing what? Software application hardening. Now, we say that we are going to look at security baselines and just get to understand what they are. So a baseline defines the expected condition of a system. Remember when we were talking about, when we were looking at that example where we were checking the requests that are coming from server 1, and then you discover that it is too many requests, and then now the firewall refuses, or rather the NACL refuses them access to the subnet. It's because it is used to, it knows that this is the number of requests I expect, but now I'm getting like 10 times or 100 times or 1,000 times that, so I need to stop it. So security baselines provides a starting point for determining what and how to secure. It's updated to reflect changes that are made on a system. So, for example, if currently you are expecting maybe 100 requests per hour, but now you discover that maybe your demand has gone high and you're going to be getting like 500 requests per hour, that can be updated via the rules. Then it includes enhancement and relies on updated documentation about your system. So I believe that note has been given there just to remind you that systems keep evolving over time. So it doesn't mean that what you defined 5 years ago is still what is at play today. Things change, and then you also change your rules so that your systems can also operate properly. Okay. So you see, these three have been accepted. These three are acceptable, but this one is unacceptable. So let me see if there is anything important here. Yeah, let's read this. Let's read through this. So a security baseline defines the expected condition of a system. It defines what is an accepted state of operation of the system so that you can quickly detect anomalies. For instance, suppose you establish the following baseline for a system, that the system displays a welcome page when it is idle. If you have 4 idle computers and 3 of them display a welcome page, but the 4th one shows a different page, then something is wrong, because they are all supposed to display what? A welcome page. So you can identify the problem, the problematic computer, and determine that it is in an unacceptable state because you have established the baseline. So the baseline is, it is supposed to display what? A welcome page. Supporting a small number of baseline makes it easier. It makes it easier to spot the one system that is not hardened properly. However, if you have no baseline, you cannot determine whether a suspicious event occurred because you have no way to identify security deviations. That is self-explanatory. You can derive baselines from system documentation if the documentation is available and has been accurately maintained, or in some instances, you can also come up with your own. So how do we harden systems? Common ways of hardening systems include turning off unnecessary services, as we said, controlling computer operations through group policies, then regularly applying patches and updates. Because these computers and these servers tend to run applications or apps that will require to be patched and updated regularly, maybe to seal loopholes and vulnerabilities, just to make sure that they are up to date or updated. So we talked about turning off services that are not needed. We talked about that. We talked about turning off services that are not needed. And here we are saying computer break-ins are a result of people taking advantage of security holes or problems with these programs. The more services that are running on a computer, the more opportunities there are for others to break into or take control of computer through them. You understand? Why? Because you have increased the threat surface. Okay, so for example, an open recursive domain name system, DNS server, is one that permits recursive DNS queries to be issued from off campus. Attackers can use open recursive DNS to flood a target system with DNS response traffic. This attack is a type of DDoS, or distributed denial of service. So that's an example. So you need to make sure that whatever services are running on your system are services that you need. Otherwise, close them down, especially when you're working with within a corporate network. Then, implementing corporate policies and restriction. Group policies provide a method of centralizing configuration systems and management of operating system, computer settings, and user settings. So all of that can be achieved by use of what? Group policies. For example, you can assign regular users one set of settings and administrators another set. Or you can give one specific user a particular combination of settings. So you will see this in play mostly when we now get to work with IAM, where you can have one user, give them permissions, directly attach permissions to them, which allows them to do A, B, C, D within the system. Or if you discover that you have this many users who require the same permission, instead of giving this permission to one user at a time, you can take all these users and put them in a group. Let's say, for example, you remember when we were doing the Linux lab, where we were creating a group. First of all, we created users using user add. Then we created groups using group add. Then we used was it change mode? Or was it user mode? Yeah, it was user. I believe it was user mode to now add users in groups. So you have created a group called developers, and then you have Pat as a developer, you have Joy as a developer, you have Esther as a developer. Now you want to put these developers together. You put them inside that group called developer and then give them similar permissions. But now you discover that Esther, apart from Esther being a developer, Esther is also an admin. And admins also have their groups. So you can also add Esther to a group called admins, together with Akina Purity, together with Akina Gideon as our admins. So they are there, and now they are able to do what? They are able to do their admin work. So it means that Esther, in addition to being able to access what developers can access, she can also access what admins can access. But Pat and Joy, who are here only in the dev side, they cannot access what admins can do unless they are added there. I hope that one makes sense. And sometimes you might even discover that now maybe you have this particular unique group. No, not unique group. You have this particular unique role, and this role does not have many people. It's only one person. And that one person is already in one of these groups. Say, for example, in this other group, you already have Purity. You had Purity in the admins. Now you want to give Purity another permission that is unique to her. Unique to her, maybe she wants to do something like auditing and accounting. So you define permissions for that and give them to her. So apart from her enjoying the group permissions that have been given to the admins, which she's part of, she's also able to do this particular. She's also able to access this other thing that is this other role for auditing and accounting. I hope that one makes sense. But we will talk more about that when we'll be doing identity and identity access management. Yeah, identity access management gets me confused sometimes. So that is very, very important. That's very, very important. So always download, when it comes to patching, always download the security and critical updates to operating systems released by software companies to protect against malware and security exploits. Please, when you are looking for patches or when you're looking for updates, even when you're just looking for new application that you want to install, if this application is available in the vendor site, in the official vendor site, please upload it from there, because it's very possible. Wale watu wa Pirate Bay. Now, it's very possible for guys to go to these other places and get what they call cracked version of, say, a software to install in their machines, not knowing that some of these cracked versions come bundled with malwares that will now start causing you problems. Then you start wondering, why is my disk getting filled up? Why is my computer overheating? Why am I getting these pop-ups? Crazy pop-ups. Some pop-ups are not very, very, very eye-friendly or public-friendly, So all that, you can avoid that by using the right things. Okay, good. Woe unto you that you go to these platforms and then you download an antivirus thinking that this is an antivirus that will come to help you. You know, it will come to help you, and yet it fails to help you. Instead, you introduce a vulnerability to your system. It once happened to me. Yeah, it once happened to me, and I did not like it. I did not like it. So it's best that you don't do that. Best that you don't do that. I can see you saying, okay, very nice, very nice. Pirate Bay. Yes, Pirate Bay. If you don't know about Pirate Bay, please don't ask. Pirate Bay is not for the. And there's this one. I get into pc.com. Where that one looks like a phone number of a hacker. I get into pc.com. Where? Okay, cool. Cool. It's good to see that people know these things. So always tread on the security side, on the secure side. So for example, security breaches are regularly discovered in Microsoft Windows ActiveX and .NET Framework. By installing security updates, you avoid damage to software, data loss, and identity theft. It's important to install updates quickly because malware can spread within hours after it has been introduced to your system. You know, after it has been introduced to your system. So it is very, very important. Try and just stay away from malwares. Malwares are just, well, they are just bad news. You know, they are just bad news. Cool. So Linux processes. You remember this black screen, eh? You must be remembering this black screen because you are dealing with Linux the other day. So Linux processes systems are not pre-hardened by default. Run process in the foreground or background, deactivate unused services or prevent them from starting automatically at system startup. I've actually been able to do this one with Windows, but with Windows, you know, we do a lot of ClickOps. You go and define which systems are supposed to start automatically at startup. You know, I used to have my Discord starting automatically, then I stopped it. Then I discovered that it's important for it to start automatically because sometimes I need to read some stuff. So yeah, you choose what you need. You choose what you need. So for Linux, you run, and then there's a way that you can actually tell which services are needed. But again, this is above the scope of this class. So we leave it at that. Then also, as a way of patching, as a way of hardening our system, we can implement patching, which I already talked about, but let's just go through this slide. So what's a patch? A patch is applied on a system where a weakness was discovered. Yes. It fixes a performance or feature issue. Yes. It reduces the types of methods that can infiltrate the system. Yes. It makes a system more reliable and secure, and it comes as an update for the software or as part of a collection of updates. And Windows really, really likes this. Windows really, really likes this. There is something that I used to dislike about Windows. At least I've not seen it happen with my current version. But when you are about to log off for the night, it tells you that there are these updates that are available. Do you want to install them? Okay, you say yes, restart and install. And then after you've given it that permission, it starts bossing you around and telling you, oh, do not turn off. Please do not switch off your machine. So you have to sit there. And then sometimes you do that overnight and then it is done. You log off your machine and then you go sleeping. Then in the morning when you wake up, the first thing it remembers, it says, oh, yes, yesterday we downloaded some stuff, but I need some time also to patch your system. So it tells you there, okay, we are patching. Now it starts rotating. It rotates. 10 minutes gone, 20 minutes gone, still rotating. Then when you're about to give up, it tells you that now I'm finished doing what I was doing. All that process is important. Please don't skip it and don't turn it off in your machine because it is meant to protect your system. You know, it's meant to protect your system. I think the only way to make sure that it happens faster is by allowing those systems, or you can actually automate it to be happening maybe at some fixed time, maybe at night or stuff like that. And then when it tells you that now it has downloaded stuff and now it wants to install, just give it the time. I don't know if you have ever noticed, but computers, it's like they have a mind of their own. When you are trying to rush things and you want things to work very fast, that's the time they will decide, yeah, we'll make you wait. And maybe it will hang for you. Kidogo, it will crash on you. Okay, that's a worst case scenario, but it will really, really hang. and then cause you to exercise what we call patience. You know, what we call patience. Yes. Thank you, Salem. Yes, we taught this when we were doing Linux, where we were talking about using top command. We were talking about using tail command. We are talking about also using head command, and there's also htop. Awesome, cool. So this is what patching does. So you can have a hotfix, you can patch, you can update, or you can use service pack. So all of these are normally, you see they are being pulled or downloaded from a vendor site through the router, and then it comes into your various workstations. You know, it comes through your various workstations. Another way to harden a system, as you have said, is to apply patches regularly through a centralized process. Patches can affect firmware, the operating system, applications, and other software. Patch Manager, a capability of AWS Systems Manager. So there's a service called the AWS Systems Manager that has Patch Manager as one of the services within it. Automates the process of patching managed nodes with both security related and other types of updates. You use Patch Manager to apply patches for both operating systems and applications. So once you have your workloads running in the cloud, you can go to AWS Systems Manager, and then you can do your patch management. So let's see if we can, I hope this is possible. Systems Manager. So this is the Systems Manager. Let's see if it will open Systems Manager. Just want to show you how it looks like. So you see every service you want to access, you search it up there. Then we are talking about Patch Manager. Let me see. Yeah, here it is. Here is the Patch Manager. When you click on the Patch Manager, oh, yeah, we are not able to access that one, but it's there. At least you have seen it. You have seen it. That's the Patch Manager that we were talking about. That's the Patch Manager. Okay. So common system hardening recommendation. So we have a client and we have a server. So for our client, you can see we are being told turn on antivirus and firewall, run fewer application, apply updates when they are released, limit removable media, control downloads, restrict terminal services, and monitor the environment. That's what you can do on your client. Now on your server, you have to restrict physical access, use dedicated roles, secure file systems, use encryptions and PKIs, use alerts, any update when they are, apply updates when they are released, and limit administrative access. In other words, limit root access to your server. So that is that. Then let us also quickly look at software application hardening. So when you're talking about software application hardening, examples include patching standard and third-party application automatically, using application firewalls, using antivirus, malware, and spyware protection applications, using software-based data encryption, using CPUs that support Intel Software Guard Extension, SGX, Intel Software Guard Extensions, SGX, and using a specific application that manages and encrypts passwords for improved password storage. The notes is yours to go through, and you see they've mentioned that Amazon Web Services offers well-architected best practices that can help you build securely in the cloud. These practices include security groups, which we've discussed, AWS identity and access management, which we will also talk about, and list privilege and access control list. So these modules that those topics that you've seen there will be discussed later. And then we mentioned server hardening in passing. So maybe we can just dive deep kidogo and say, for server hardening, you can divide it into FTP server, directory service server, and DHCP server, and DNS server. And then you can see the various things that you need to do in order to make sure that you have hardened them. And I'm not going to read through all of them. I'll just give an example. For FTP servers, just make sure that you isolate folders and you activate anonymous mode and do all those other things that have been said there. And then for directory service server, you need to implement strong authentication and encrypt traffic alongside what has been stated there. Then for DHCP, for DHCP, server, you need to activate port security, monitor it, and then also isolate roles. And then now for DNS server, of course, you will need to fix writable cache problems to protect against spamming events. And then also use domain name system security extension, DNSSEC, with trusted servers. So there are various suggestions that you've been given, which you can use, and most of those are properly explained in these paragraphs for your own consumption. Then, mobile device management, MDM. So remember, when we are talking about bring your own device, we say that there's also mobile devices that needs to be managed properly. So use MDM solution to secure and control mobile devices. And you see those devices need to be patched. You need to understand their running environment. You need to make sure that they are properly configured, that they have security software, and that they follow all the security standards laid down by your organization. And as you can see here, we have MDM, our MDM at the center of it. So for securing mobile devices, we are told, use a mobile device management solution. So you can use MDM to enforce corporate and security policies regarding the use of devices. Companies that, sorry, let me swallow water. Better. Cool. So you are told, use MDM to enforce corporate and security policies regarding the use of devices. So companies that permit bring your own device, BYOD, should implement MDM. That's very important. AWS has services that are specifically equivalent to each MDM solution indicated here. One example, installing patches by using AWS Systems Manager, which we have talked about. It has a patch manager. And then another example is AWS Config, a very important service that we'll learn about later, which you can use to assess, audit, and evaluate configuration of your AWS resources. AWS supports security standards with data protection services that help you protect your data, your accounts, and workloads from unauthorized access. Very important. Training and education. When you're working in an organization, we say that the biggest link, the weakest link in your security, in the security of your network are the people. So one thing that we should do as an organization is to invest in training your people. Sometimes people expose themselves to these vulnerabilities because they don't know. Like for example, there is this type of attack called a phishing attack, where you might be sent an email that looks like it comes from Landly, but it's not really from Landly. And now it is requesting you for your PII. PII is personally identifiable information that can actually be used against you in things like identity theft. Or it even asks you for your credit card information. I know we are in Kenya, credit card is not a thing, but it asks you for let's say, your banking information, things that can be used to clone you and con you. Yeah, so training and education are the most effective defenses to harden systems against social engineering and phishing attack. So fact that they can clone and con, that is normally done mostly through social engineering, and phishing attacks is where you receive an email, you think that it's coming from this particular place, kumbe wapi. And I know for the Kenyan context, it's very easy for us to receive. You see what we receive on phone, that congratulations, umejishindia shilingi this from this company. A friend of mine told me that one day the father received a message telling them that they have won a jackpot for participating in Jishindia Sijina Tasker, and then the father does not partake and has never partaken in that, and then said, around here they did what? They waligonga nje. they missed their mark. So we've been having those things coming to our phones, those fake thingies. Some of them are outrightly malicious, trying to con us. And then sometimes you even receive an email telling you that, oh, you've won this. And being that you've been online for the longest time, you might even fall prey to those. And then they tell you that you've won this. Then when you start going through the processes, they tell you that, I don't know, you need to pay this much in order, I don't know, for postage or for shipping. And then suddenly, phew, it's gone. And it even becomes worse when now you are doing it in an organization. You click to a link, and then that link exposes the organization, and then now things come in. Now, when you are training your employees, you need to remind them of the policies that are existing, on policies and how these policies need to be enforced. So before enforcing any policies, it's best practice, first of all, to inform your employees and train them on these policies, so that when they are doing their work, they will know, by this has been cautioned against, and we need not to go against it. Anyone that breaks it, then it will be bad. Then policies always come first. Get management on board. It's very important for management to be on board with this kind of a paradigm. And then also enforce consequences for non-compliance. For instance, if you've told them that site A, B, C, D is not supposed to be accessed through the corporate network, then anybody that breaches that, they need to know that there are consequences for such non-compliance. So social engineering is an attempt to circumvent administrative, technical, or physical controls by conning individuals. You see, I say they dupe you, then they con you. Social engineering takes advantage of the following circumstances. Now, future employees in this call, pay attention. Bad or lazy habits that break normal security procedures. Be careful of that. Lack of financial or other penalties for giving up information. You see? Then inability to trace a security leak back to a specific employee. If your system cannot do that, then that is bad. Then short timer attitude among employees. I want to be here when they investigate. You feel like you are a transiting employee. Yani, you've just joined the organization, but you feel like you'll just be there maybe for 2 months, 3 months, and then you'll be off to quote unquote greener pastures. Then lack of enforcement of existing policies or other controls. And finally, lack of maturity in training or tools to combat social engineering. So you see training as featured here. So this is how you defeat what? This is how you defeat social engineering. Let me check. Yeah. Let's see. Frank has shared something interesting. Let's use it as an icebreaker. Sent a salary review phishing email to all staff this morning. Data protector officer clicked. That's an interesting one. Yeah, because everybody wants to have their salaries reviewed. I would be okay. It wouldn't shock me to learn that maybe even the same email reached the CEO, and the CEO also clicked it. Yeah, because people always are looking to earn extra. To earn extra, which is not a bad thing anyway. Cost of living, as cost of living goes up, you also expect your salaries to be reviewed upwards, So let nobody lie to you. If someone asks you, why are you doing what you do? Don't exercise false humility. Tell them, it's not about the money. It is always about the money. Actually, the money is the biggest motivator. If it's not for you, maybe you can tell us. If it is not for you, if money is not your motivator, there's a clip I saw. Because of time, I'm not going to play it. I'll try and find it over lunch, and if I find it, maybe you can play it in the afternoon. About a guy who was in this panel, and then he was being asked, how much do you want us to pay you? And then he was saying that, for me, experience is important, the ambience is important, and I want to grow with the company. So I'm also willing to work for free, I'm also willing to work for free. And then the boss moved on to the next person. The next person quoted their salary, and the boss said, okay, I think you can negotiate over that. And then now our friend Tom felt like he shortchanged himself. And now I was telling my friend with a quote, don't be like Tom. Don't be like Tom. Don't be like that person that goes there with false humility. You know, you are a cloud engineer. Yeah, Dr. Tom. In addition to the 5K, he was given some chai and mandazi. You know, So it's totally sad, So we are talking about social engineering. So let's just go through this. You are at work. If you notice someone that you don't recognize in your area and they don't have an employee badge, will you challenge them? If you notice someone in your area and they don't have an employee badge, will you challenge them? Number two, what about someone that you know who doesn't have their employee badge? Will you challenge them? What if the person is high on the organizational chart? What if the person is high on the organization chart? Then, how might social media sites be susceptible to social engineering attempts? So these are just things that you can think around, and maybe when we get time next time, we might even discuss them. But basically, social engineering takes these kinds of shapes and forms. Someone might be lacking an ID card and they are in your area. It might be a new hire on the positive, or it might be someone that's not authorized to be there on the negative. You know, or someone that you know and then they don't have their badge. Like I remember the same place that I used to work, the security guys, because we had security guys on every floor. So in as much as they know me and they see me every day that I check in, if I don't have my badge with me, I wouldn't actually be allowed to get even into the elevator. I wouldn't be allowed. So you always had to have your ID badge with you at all times. And those things are for security. If a person is high on the organizational chart, it means that maybe they are your boss or your boss's boss, and they don't have their cards. Yeah, I used to see that a lot with the CEO of that organization. Everybody else had to have their badge. Him, no. But it is a forest where not all animals are equal. Then we also have this issue about how might social media sites be susceptible to social engineering attempts. If you've ever been hacked, if people have ever posted things that you consider unpalatable on your timeline. So that's the question that you are being asked there. Okay, that's the question that you are being asked there. Just bear with me. I will be done in like 5 minutes. I'm so sorry for taking your time, guys. But we had to teach both of this. We had to teach both of this. So I hope you guys are understanding. And it's not even hard stuff. So when it comes to system hardening, AWS has tools that can help you to harden your system. So some of the tools that you can use to harden your system, and we will revisit them at some other point. So AWS provides many different security tools to help customers keep their AWS accounts and applications secure. So one of them is AWS Trusted Advisor. The work of Trusted Advisor is to check what you have provisioned and then advise you if you have over provision or if you have under provision, or if you have areas that you can harden. It will tell you. Amazon Guard Duty, that is a security service. Amazon AWS Shield is a security service. And Cloud Trail, Trail, it looks at who accessed what, when, and where, so all that. So let us briefly read about them. Trusted Advisor provides recommendations that help you follow AWS best practices. So Trusted Advisor evaluates your account by using checks. It checks your account against a checklist, and then it tells you, you pass here, you pass here, you fail here, you fail here, do this to pass here and pass here. Okay. Then we have Guard Duty, which is a threat detection service. Guard Duty continuously monitors your AWS account and workloads for malicious activities and delivers detailed security findings for visibility and remediation. So it is a threat detection service. Just remember that. Threat detection service. Shield is a managed DDoS protection service that safeguards applications that run on AWS. Okay, so Shield is a managed DDoS protection service that safeguards applications that run on AWS. And then we have Cloud Trail, which offers auditing, security monitoring, and operation troubleshooting by tracking user activity and API usage. So don't worry about all of this. We will cover them better when we get into services. And also when you are looking at some questions, you will meet them. Missing. Cool. So after this, we are going to the checkpoint questions. So guard duty uses threat intelligence feeds such as list of malicious IP addresses and domains and machine learning to identify unexpected and potentially unauthorized and malicious activity within your AWS environment. So think of guard duty. Not a guard. So you know guard, you know a guard. A guard, the work of a guard is to stay alert and check. So they are checking. So it uses threat intelligence feeds, such as the list of malicious IP addresses that you've blacklisted and domains and machine learning to identify unexpected and potentially unauthorized and malicious activity within your AWS environment. So we have AWS, you have AWS CloudTrail that is monitoring, guard duty that is detecting, Lambda that is responding, and Security Hub, or even in combination with the likes of Inspector that investigate. So this is your investigative workflow. You see how the services work together? No service works in silo in AWS. So those notes are yours to read. So let's look at these checkpoint questions very fast before we go for lunch. What are the common ways to harden a system? What is the purpose of patching a system? Which AWS tools uses threat intelligence feeds such as list of malicious IP addresses and domains, or to identify unexpected and potentially unauthorized activity within your AWS environment? Starting with the last one, we've just talked about it right now. That is the work of guard duty. All right, there it is. Guard duty. The second one, the purpose of patching a system is to repair a vulnerability or a flaw that is identified after the release of an application or a software. After the release of an application or a software. So patching is very, very important. Then what are the common ways to harden a system? One is we turn off services that are not needed. We implement corporate policies and restrictions, and then we regularly apply security updates and patches. All right, someone unmute. Who read the other time? Was it a lady? Yes, a lady read the other time. So, Agent, please unmute and read these key takeaways for us. A gentleman, kindly.
Can you hear me?
Yes.
Okay. The goal of systems hardening is to reduce the set of vulnerabilities that a system exposes in order to minimize security risks. Effective techniques to harden a system include establishing a security baseline, turning off unnecessary services, and applying patches regularly. Systems hardening must balance restrictions with the usability of the system.
Awesome. So you see the balance. I like this last one. System hardening must balance restrictions with usability of their system. So that is awesome. That is that. We are not going to do this lab in class. This one you'll do it by yourself. I did the first one for you. So this one you'll do it by yourself because it's relatively long. And actually the best way to do this, I propose that you do it in your groups. So find time and do it in your groups. You'll see in the afternoon if we will have time to go for group work. Let me see how the module looks like. Let me see if we will have, if it comes with a lab. If it does not come with a lab, even better. Because I need you to do this too. The two labs that we've done today, you do it today so that it does not pile. So we will be doing, nice. So in the afternoon, we'll be doing prevention data security. So you'll be doing data security. Yeah, it has a lab, but I suspect this lab is relatively short. So guys, just plan yourself, team leads, tech lead, and organize meetings where people will be able to meet and do this lab. And so for this lab, what you guys will be doing, you'll be patching Linux instance using default baseline. You'll create custom patch baseline. You'll use patch group to patch window instances using custom patch baseline. And then you'll also verify patch compliance. So this is a very nice one. And if you're interested in systems administrative work, please pay very keen attention to this lab. This will give you a feel of what sysadmins do. You know, it will give you a feel of what systems admins do. So we'll end it there for now. We'll end it there for now so that you guys can go for your lunch. I hoped to have finished by 12:30, but I've gone 15 minutes past. I hope you guys will be able to grab something for. I promise you, the afternoon class will be a bit relaxed. It will not be as fast paced. Sorry if you feel like you are overwhelmed with content, but yeah, we are here to help you guys. So thank you so much for being in class. So yeah, you are allowed to go for lunch. Yes. See you at 2. And wait, before you go, we are getting a bit concerned about your numbers. I don't know why these numbers are dwindling. We are 30 in this class, and actually out of the 30, interestingly, out of the 30, 3 of us are not part of the class. That is myself, that is Joy, and that is Esther. We are not part of the student population. So out of 31, we are 28 in a class that is supposed to have 46. That's a very low number. And you know, we are not going to repeat teaching what we've taught. So guys, please pay attention. Please try and avoid absenteeism when you can. Okay, so see you at 2, and I hope to see all of you back here. Cool. Bye-bye.